Hello, everyone, and welcome to the Global Azure Norway. My name is Håkan Silvernagel. I am part of the Norwegian.net user group who is arranging this conference here. And I'm very, very proud and very happy to introduce our opening speaker here, Stacy Cashmore. Hi, Stacy. How are you?
Disappeared. Am I back?
Yes.
Oh,
you're back.
this is always good at the start of an online session. Have your wide internet connection do something interesting. Let's make life exciting.
Yeah, I think we're all pretty used to that nowadays. So just a short background here. So Stacy is a tech explorer, DevOps at Omniplan, and also a Microsoft MVP in developer technologies. And she's been developing software since the mid-1990s and has been speaking about how we can improve the way we develop software, both at conferences and meetups since 2018. And as well as sparring with a software architect about technical issues, she also spends her time helping the development team and also the wider company with continuous improvements, both in terms of technical risk, process, and of course, working together as a team. And outside the work, she enjoys spending time with her classic car, cooking, playing the piano, and spending time with her family. And doing, amongst other things, building a Lego model building city in their house. Yes. So what will you speak about tonight, Stacy?
Tonight, I am going to be going on an absolute whirlwind tour of Azure Static Web Apps and how we can use them to build up our own personal brand and get ourselves out on the internet just a little bit more.
Yeah, fantastic. Take it away, Stacy. The stage is yours.
Thank you. So, hello, everybody. And, well, like I say, it's building your brand with static web apps. I saw a tweet sometime in around 2021 on my timeline that was talking about building your own brand. Basically, if you blog and you put your blogs on somebody else's network, then no matter how good that network is, you're using your time and skills to build up their network rather than your own. I thought, well, they kind of have a point here. So I decided to buy a domain. And actually, I didn't buy one domain because whoever buys one. I bought 3 so that I could start doing this myself. So I have stacyclouds.net, .com, and .dev. And once I had it, I did nothing because buying a domain and using them are 2 slightly different things. And the problem that I had is thinking about doing everything to get something out and having a reasonably professional looking site with nice hosting. And it seemed like this huge challenge to kind of get over. And then I started playing with Blazor. And then I started playing with Azure Static Web Apps. And I saw this simplified, cheap way to get a front end and an API out onto the web, removing the need to configure cores and all of that glue that make websites work, one single Azure resource. So I started to play with it and I started to build my own site. Now, my site is a work in progress. You know, it's going to be for quite some time yet, but it is moving along slowly. I am adding new features when I have an hour or 2 to spare, which is perfect for something that is supposed to be a little bit of a hobby. So what I want to do today, like I say, a really whirlwind tour of using static web apps with a Blazor WASM application and some Azure function goodness thrown into the backend as well to try and tell the world who we are. So who am I? I am Stacy Cashmore. I am Tech Explorer DevOps at Omniplan, which is a financial advice software company based in Amsterdam in the Netherlands. As Håkan said, I have been developing since the mid-1990s. And yeah, I'm really honored to be able to call myself an MVP in developer technologies. And I've been playing with Azure Static Web Apps since they were in general availability, seeing how they've evolved. And like I say, putting my personal site out there using it. So that's enough of me talking because we've got a lot to get through and me talking isn't helping that. So what we're going to do to start off with is create our application. Now, my blogging platform of choice is dev.to. I have a number of blog posts there, and to be honest, I still publish my blog posts there, even with my website. What I don't do, though, is only have them there. So what we're going to write today is a small blogging application, and it's going to read our blog posts from dev.to and allow them to host them locally with our own website and build up our own brand without having to do a whole blogging website before we begin. So number one, we are going to create a new project, and that new project is going to be, come on, little computer, you can do this. I know it's been a long day. A Blazor WebAssembly app. And we need the WebAssembly app because we are going to be deploying static files. Now, we're going to call it client because it's our client. And we're going to be hosting this in a folder so that all of my GitHub repos work. And the solution name, I also need a special one to make sure that my GitHub repos work. And that's going to be Blazor Talk Demo. Now, we're going to be using .NET 6 long-term support for our project here. We're not going to be looking at authentication in the start. I'm going to configure for HTTP, of course. We are not using an ASP.NET Core hosted Blazor site here because, of course, even though that still runs in the browser, it still needs a web server on the back end to serve it. We don't want that. We just want the static files that we can push out there. And we're not going to do anything with a progressive web app because that's just not functionality that we're going to be using today. So hopefully this is going to scaffold up reasonably quickly. There we go. And to this solution, we're going to add another project, and that's going to be our Azure function. This is where we're going to get the dynamic data to push out to our static application. And we're going to call this API. We have a client, we have an API. The naming for this, you'll see why I've picked it in just a couple of minutes. So we want a HTTP trigger, and we're going to bring this up. And the first thing that we're going to do now that we've actually created this, assuming my machine ever comes back to life, come on, machine, you can do this. We're going to do a little bit of cleanup. I don't quite know why my properties window is going weird, but we'll just close it. We're going to get rid of everything that's scaffolded by default that we don't need in our application. So let's get rid of this function 1 because I hate having things called function 1, class 1, function 1. It's annoying. We're going to get rid of the pages we don't need. Anybody who's ever scaffolded a Blazor application, you get a counter page so that you can see that you can click a button and you can count the amount of clicks. And you have a fetch data page where you can get data from a sample data JSON, which exists on the site. Like I say, we're not going to be using these because we want to get something that just contains our content by the end of today. So we'll get rid of those. We're just left now with the index.razor. And for this one, we're just going to clean this up a little bit. And we're going to call this Global Azure Norway. And we're going to go, hello, Norway. So we have a nice, clean interface now. Few of the things that we're going to clean up. One is just some Razor files that I don't particularly want in my application. And because we've got rid of those 2 extra pages, we're going to remove the navigation links to them because the last thing we want is links that don't work on our website. And then one final one, we're just going to get rid of the link to the Microsoft Docs. Because again, if we're making a website for our things, we don't want that in there. It's useful when you're learning, not useful when you're deploying something. So let's quickly build that and make sure I've not done anything wrong. And then we can proceed to actually making something useful. First thing that we're going to do is write an Azure function, which is going to go out to dev.to. It's going to read all of my blog posts in, and it's going to make them available for that Blazor front end. So to start with, we need a model that we can use. So let's make a new folder here called models. Come on. Add new folder. Thank you. Models. And inside there, we're going to make a new class, and we're going to call that blog post summaries. So let's add a new class. Call it blog post summary. And there we go. Now, because you don't want to watch me do typos for the next 45 minutes, or maybe you do, but I don't particularly want you to see me doing typos for the next 45 minutes, I've got an amount of snippets that I'm going to bring across, but I'm going to explain them to you as we do that. First one is the class that we're making here just holds the information about our blog post summaries. So the ID, the title, description, the URL to get access to it, and the date that it was published at. We are using the system text JSON serialization because the data we get back from dev.to isn't quite in the format that we want in order to be able to use on our website. So we're just going to throw it in here. Now that we've got our model, we can actually make our new function. So let's come and add a function here. Add new Azure function. We're going to call that blog posts. And that, of course, needs to be a HTTP trigger, which is the only type of Azure function that you can put inside of a static web app, if I remember correctly. And we're going to replace all of that too. Let's make some space so that we can see what's going on here. We have a function which is available on a HTTP GET, and it's going to be on the blog post route. So API/blog-posts. Inside of here, we're going to get a HTTP client, which we're going to look at in a second. We are going to go out to articles with the username of my username on dev.to, Stacy_Cash, and we're going to get all of those results. And then we're just going to deserialize that JSON into an IEnumerable of blog post summaries and throw that back to wherever we're calling this from. The HTTP client, well, that is slightly interesting because dev.to changed their API sometime last year and everything on my website stopped working for a couple of days. They introduced the need to add a couple of different header values into the requests. So that's why I just make this one here, just to put a couple of extra bits of information to make sure it works. Not an overly complex function to make sure that we can get stuff out of this. Next step, we're going to make our front end. So inside of our client, we are going to make another models folder. Now, I'm going to be honest here. On my website, I do not do it this way. I have a shared folder, a shared project, and that project contains the models that I need between the API and the front end. However, adding an extra model, an extra project, takes more time than just adding the classes twice. So for a demo, I cheat. I'm sorry. Bring the code in here, and this is exactly the same as we had on the back end, just without all of that JSON.text notation. So we have our ID, URL, title, description, cover image, which we're not going to be using today, and the date that it was published. Next, we're going to need to have a service that actually fetches our data for us. So we're going to add another new folder called services. And inside of there, we're going to make a blog post summary service. So we're going to add a class. And what this service is going to do for us is call the API and hold the blog post summaries that we get back. So that inside of our application, we only have to make this API call once for each visit to the website, and not each time we load the particular page in our website that actually displays our blog post summaries, just to make it that little bit more efficient, make our application that little bit snappier. The way that we do this, we inject a HTTP client into our service, and we have a public list of blog post summaries available for the outside components to use. We also have this load summaries function, and this is called from the different components that want to get access to blog posts. And what this basically does is just say, if I don't have any summaries yet, if my summaries are null, then go to my API and get my blog posts. If I do have summaries, nothing happens, and I don't waste that network call. Last thing that we need to do to make this usable inside of our application is add it to our dependency injection container. We do that inside of the program.cs. And if we just do a control dot, then we can bring in the using statement. Honestly, we can, if the computer does what it's supposed to do, so that we can get rid of the red squiggly line. Another quick build to make sure that I've not done anything wrong. Now we need to show the blog posts. And for that, we're going to add a razor page. So in our pages folder where I deleted the counter and the fetch data, we're going to add a new Razor component, not Razor page. We don't use Razor pages inside of a Blazor app. We use components and turn them into pages. So we're going to call this blog posts. And yet again, we have a snippet to bring over. So inside we have this page directive. This is how we know that when we go to blog-post, this is what we're going to see. We're using the client services and we're injecting that blog post summary service so that we can use it inside of our app. Then we have our page title and our header for the page. Interesting, that looks the same, but they do different things. The page title actually goes on the tab and the H1 is for the actual page itself. Then we have the fun stuff. When we access the service.summaries, if that's null, we can assume that we are loading our blog posts. So we have loading ... Once we actually have blog post summaries, then we can loop through each of them. And for each blog post, we're going to put on the page the title, the published at date, the description, and the URL with a click out to a new window, because I don't want people leaving my website yet, to the original article on dev.to. Finally, at the end, we have this code block where on initialized async, we call that service.load summaries to make sure that we have this data available to us. There's one last thing that we have to do before we actually send this out, and that is give our users the ability to get to our blog posts page. For that one, we're going to go back into our nav menu. Remember, we removed those two navigation links that we don't need, and we're going to add a new nav link. And we're going to put our blog post on the page. It's going to link to the blog post pages inside of our site, just so that we have easy access. One last build to make sure it's working. And now that's it. We have an application that we can push out, which is going to get those blog posts and make them available to the users. So let's push this up. There's one thing I want to show you before we push it up. That is my Git repository. This is a repository we're going to use, and you can see right now it is empty except for a git ignore. So I just really want to prove to you that we are starting from scratch here. So add app. So let's commit all and push. Let's hope that the internet connection is working well enough to get this out. Yes, awesome. And if I refresh my repository now, we have our application. Now let's get it out to users. For that, we're going to go to the Azure portal. Now, I already have a resource group set up for my static web apps. And inside here, we're going to create a new one. So we're going to search for static app. We're going to create a new one. And whenever you create a new one, you need to check that your subscription and that your resource group is correct. It should always be, because we created it from inside of the resource group. But spoiler alert, it's not always. Make sure you double check. Then we need to give it a name, and we're going to call this a SWA demo. Now, you'd expect that name to be used inside of Azure if you've ever used app services, where they have to be globally unique inside of the whole of Azure. For static web apps, it only has to be unique inside of your resource group. Azure will make its own URL for you, so you can pretty much put what you want here. Next, we need to pick the hosting plan that we want to use. Do we want a free plan for our personal or hobby projects? Or do we need to use some extended functionality like private endpoints, like custom authentication that you need to pay for? If you do, you can go for the standard plan. I believe it's around about $10 a month. So it's not overly expensive for the functionality that you get out of it. Then we need to say where we're hosting it. I'm hosting it in West Europe because I'm based in the Netherlands. And as it says on the screen, this is where our Azure functions will run, and this is where our staging environments will be created. Your actual application is globally available. It isn't tied to a particular region, but your staging environments and your functions, they do run in a particular place. So try and keep them close to your users if you can. Now we get on to the bit that I really love about static web apps, where we're going to deploy our data from. And we don't actually have to set up our own CI/CD pipeline if we're using GitHub. I can sign into GitHub on a separate screen so I don't dox myself. And come on, which password is it? It's that password. And once you're signed into GitHub, you pick your organization, you pick your repository. and I want Blazor Talk demo, and then you put the branch that you want to deploy. And what this will do for that repo, it will create you a CI/CD flow for that branch so that whenever you make a change, it gets pushed out. What do we want to build? So our build presets, here you can pick from a whole list of frameworks that we can use. So we have Angular, Blazor, Next, React, Svelte, Vue, Gatsby, Hugo, VuePress, or you can even just do your own custom. As long as it is static content, you can host it here. So we're going to choose Blazor because that's what we're deploying today. And then we have 3 more values to set before we're finished. We have our client, our API, and our output location. So app, API, output. Why did I pick client and API for the names for my projects? Because that is what is default in our setup when we create it. If you're deploying Blazor, the output location pretty much doesn't matter as long as it doesn't exist inside of your repo. If you're deploying something like Angular, it is extremely important and you have to do some research to make sure you point it to the right way. So let's create our static web app. The other great thing, most of the time, static web apps are created in just a couple of seconds. So it should be available to us really quickly, like that. And when you create it, you see that we have this URL created. So for today, our website is going to be a lively mushroom, which is kind of cool for a website when you think about it. If we open this in a new tab, we can see that we have a page available live on the internet for us. Unfortunately, it says your Azure static web app is live and waiting for your content. Well, I'm supposed to have a CI/CD flow, so where is my content? Well, let's have a look in our repo and see. If we refresh the page, we'll see that we now have this workflows folder. And here we have an actions file. The bit that I want to draw your attention to is this. We are using a static web app deploy, and that takes secrets which are put into your repo by the portal. That's why you have to log into your GitHub repo. And what it's going to do is look inside of our repo in the client folder and in the API folder, and it's going to figure out what it needs to build. So you don't need to actually tell your flow that it's building Angular or it's building a TypeScript function or it's building .NET or Blazor or anything else. It will try and figure it out itself, which means that if you ever do change from Blazor to Angular or from Angular to Blazor, this should work already out of the box. The only thing that you're going to have to do is make sure that you are picking your code up from the right place and deploying it to the right place. And in fact, I've actually done this because I changed one of my demos recently from Angular to Blazor, and I just had to point this to the right place and everything worked. So what we get from this workflow is this CI/CD run, and this is now deploying our website. Generally takes between 2 and 4 minutes. So since as we have a lot to get to, we're not going to watch this page for 2 minutes. Instead, we're going to come back to our code because I want to run this locally as well as running it inside of Azure. Now, in my intro, I said that Azure takes care of all of the fun stuff trying to connect your static files to your API. Awesome in Azure. What do you do when you're running locally and you don't have that glue available? Well, for that, I want to briefly introduce you to the Static Web App CLI. What this does is you can install it from NPM. I'm going to put links to loads of stuff in Twitter, and I believe they're going to come into the chat at the end of the talk as well. And this is a Node.js server which replicates the functionality of an Azure static web app. Really important, it replicates the functionality. It does not give you a static web app on your computer. There are going to be slight differences, so always test in Azure, but this is awesome for debugging. So what we're going to do, we are going to come back into our app, and we're going to change our startup files, because one thing that we do need is both our API and our project running. So if we start this and we start this, start this up, and hopefully this is going to bring up a, whee, come on computer. Thank you. So here we have our Azure function tools, and here we have our app. Now, if we click on blog posts, we get this error because this is running on 7195 and our function runs on 7071. So what our static web app CLI is going to do is, if I can remember the URL that it's running at, it is going to take everything that comes to the static web app and it is going to forward it to 7195, except for calls to things inside of the glue of a static web app, and it's going to take care of that itself. So API calls will be forwarded to our functions, and hopefully our site should work as we want. So I want HTTPS localhost 7195. This should hopefully start up in not too long an amount of time. Come on, little computer. Thank you. We now have this 4280 website. And if I copy that and bring it into the same browser that Visual Studio opens, it takes a little bit of time to run when you load the whole site because the static web app CLI, it is slightly slow when you're loading a Blazor app. It is quicker than this in production, honestly. But it's going to bring everything in. And when I click on blog post, it's going to go to my backend. It's going to bring all of my blog posts. This is what I have on dev.to. And if I click on a link, we open dev.to, and there is my full blog post. This is my first step to getting my brand available online. Now, I said that this has to be ran inside of the browser that Visual Studio opens. We need to do that for debugging purposes. If I come back to my solution here, and I want to put 2 breakpoints in. I want to put a breakpoint in my API, and I want to put a breakpoint in my blog post Razor page. So now, if we go back to the app, where is my web browser? There's my web browser. Let's refresh this page, and we have to wait for everything to load again. Sorry about that. Okay. We now have a breakpoint inside of our Blazor app. This is good. This is the first thing that we wanted. So we can debug our client code. If I click play, I can now debug my API code. Perfect. I've got a really nice developer in a loop now. And that static web app, I can ignore now. All I need to do is I can stop my front end, my Visual Studio. I can make my changes, restart it, and that static web app will still work because it's just listening for requests. Why does it need to be in this browser? Well, for the Blazor debugging. If I go into my other browser and I try and put my localhost here, it's going to load up. We get our breakpoint inside of our API, but that's it. We don't get it inside of our Blazor file. And that's because when you start a Blazor debugging session, there's tunneling going through to that browser. If you go to a different browser, you don't have that tunneling. So just bear that in mind when you're working on it. So that's how we can do debugging locally. Now we can see that our run is finished. So if we refresh this page, we should now have a Blazor app running in production with access to our blog posts. And there we are, inside of 20 minutes. We have the first thing live. So that's the first steps that we wanted to take for this. The next one that I want to show you is where you're going to be a few steps on from this. We're still deploying to dev.to. At some point, maybe you want to use your own website to store your own blog posts rather than doing it from a different application. If you're going to do that, you're going to need some authentication in your website to make sure that you know who is editing it, and basically just to make sure that you're the only person who can edit it and everybody else just gets to see it. How do we set this up? Well, authentication is actually part of the glue of that static web app resource inside of Azure. So for example, if I want to log into this application now, I have added no code to allow me to log in. But if I come into .auth/login/Twitter, GitHub, go to GitHub. What this has done, it happens so quickly you don't see it, but it's gone out to GitHub. I'm logged in on GitHub, so it verifies me. And then it says, hey, this app's trying to use your data. Do you want it to use your email address and your username? And it's like, yeah, I'll let it use that. I then come back in, and we should now come back to my site. And although you can't see anything, I'm now logged in. And I can prove that to you, because if we go to /auth/me, there is my information. I logged in via GitHub. I have this user ID, and I'm not doxing myself. That user ID is unique to this static web app. If I log in on a different static web app, I will get a different user ID. My user details, Stacy Cash, because that is my GitHub handle. And the roles that I get, anonymous, unauthenticated. Every user that logs in gets these two roles. This is the standard. Now let's try and do something with these roles inside of our code. So I want to come back to Visual Studio. Let's stop the debugging. Let's close everything so everything's just a little bit neater and get started. We're going to start in the API, and we're going to add a new file, and that file is going to be called Static Web App API Authorization. Now, again, the same as with the models being shared between different projects. If I'm doing this in production and on my website, I do this. This is a separate project that takes care of it so that we can keep our code just that little bit neater. So we have quite a big class to come over, but we're going to talk about what this does. What we're going to do in order to get access to our user information inside of our API is look in this header, XMS client principal. The user will never see this header. This only exists behind the static web app, so it's safe to use, and users shouldn't be able to alter this and do bad things. Inside of this header, we have a base64 string, which contains a client principal, which is that JSON object I just showed you on the screen. So, of course, we need to have that client principal. Identity provider, user ID, user details, user roles, claims, and an access token. The claims and access token, that's used for custom authentication, so we're not going to be touching that today. Once we have a client principal, we then need to make a claims principal from it. And that claims principal, we're going to do a little bit of processing. We're going to strip off that anonymous role, because you know what? I don't care if somebody's anonymous. If they're anonymous, I'm just going to treat them like they're not logged in anyway. And in fact, if that is the only role that we have, then we just return an empty claims principal. They're not logged in. If they are logged in, if we still have roles left over, then we make a new claims identity and we strip the things out of there so that we can use it in our app to validate what that user is doing. Now, I want to add two functions to my API now to show you this in real life. So we're going to add a new Azure function. It is going to be an auth test. It's going to be a HTTP trigger. And again, I have a snippet that I'm going to bring across. In this snippet, again, we have a get root. I've not set the root here, so it's just going to be API/auth test. And what we do is go to those two functions that we talked about, the parse HTTP header and the get claims from that client claims. And I'm just going to return some information about the claims that I have. Please don't do this in production. This is a wonderful way to dox your users, but I just want to show you this working. And I want to create a second function now. And that one is going to be, because no, it's not a class. I want to add an Azure function. Of course, I want to add a new Azure function. Auth test 2, because you know what? Naming is hard. So auth and auth 2. And this one is going to look remarkably similar to the other one. Auth test 2. Name of auth test 2. And we need to make one last change down here. Auth test 2. We're going to be using this to show access control in a couple of minutes. That's why we have these two functions available. Next, we're going to add some authentication to the client side. And for that, we actually need to add a new NUGget package. We need to add ASP.NET Core Components Authorization. So manage NuGet packages, browse. We want this one. Small. Okay. We never read these, do we? We just always click OK. Now that we have the NuGet package available, we can actually provide authentication to Blazor. And for this, it's actually fairly similar to what you would do for any Blazor application. It's just where it gets the authentication data from. We're going to add a class, and that's going to be Static Web Apps Authentication State Provider. And inside of here, we're going to do some processing similar than we did in our API. That's not good. I am sure that I just added this NuGet package to the client. Did I accidentally click decline? You know, it's always fun when you're in the middle of a demo that works every time you do it, right up until the time when you demonstrate it to people. Install. Yes. I accept. Let's check my package sources. Sorry about this, people. Okay, I fear I'm not going to be able to demonstrate this to you in code. I'm going to have to look at what's going on with that later on tonight. And I will put it on Twitter about what I did wrong for this to suddenly not work when it's always worked in the past. Let's try installing the latest stable version. Is it because I had preview on? It's because I had preview on. So inside of here, what we are doing is adding authentication state. And what we're doing is getting that from the client principal. That is the same client principal that we just saw inside of the API, but it comes from a different place. In actual fact, it comes from that .auth.me page that we saw previously. So because when we are making this request, it is running inside of the client's browser. We have all of the cookies that are sent. We can go to that auth.me. We can check who the person is that's logged in, and we can use that in our authentication. Then we do exactly the same as we did before. We strip off anonymous, and then we return a claims identity provider, and we can now use this inside of our application. We're going to need to add this to our services inside of our program. So let's add another new class. Let's add authentication extensions, and let's see what we're going to add to our builder. We're going to add two things. One, we're going to add authorization core. This comes from that Microsoft ASP.NET Core Components authorization namespace that was giving me so much grief 2 seconds ago. And then we're going to add, as our authentication state provider, that static web app authentication state provider that we've just looked at. From this point on, we can add authentication inside of our Blazor app the same as we would do for anything else. So I just want to add it to a couple of places just to show it working for you. Number one, we need to make a change to make it available inside of our Razor components. And for that one, we have this wonderful underscore imports Razor. If we add a using statement to this file, it is available in every single one of our Razor components in our site. So we don't have to keep on putting it in every single page. The next thing that we have to do is make sure that we have an authentication state available in each of our components. And for that, we need to make a change to our app Razor. And what we're going to do is wrap our router assembly with this cascading authentication state. This will make sure that we can use it when we need to. We're going to use it in two places. First place that we're going to use it is inside of our navigation, because I want to give my users a login button. And what we're going to do is we have this authorized view. And if we're authorized, then we're going to show whether or not they are a standard user or a super user. and we're going to give them a logout button. If they're not logged in, then we're going to go to Twitter. Then we're going to go to Twitter, and we're going to allow them to log in with Twitter. Interesting to know, out of the box inside of a static web app, you can log in with Azure Active Directory, Twitter, GitHub, and Google. So that's one place that I want to use it. The other place I want to use it is inside of my main layout. Now, remember I deleted this top row with the link to the ASP.NET documentation? I want to add something here just to give us some feedback on our authorization state. And what we're going to do here is say, if we are authorized, show my authentication type. How did I log in? And if we're not authorized, we're just going to say not logged in. Last thing that I'm going to do before we push this up to the web again is add a static web app config. And what this is going to do is give us some control over who can access our APIs. So inside of the www root, which is just the folders that get pushed directly out to your clients, to your static apps, we're going to create a JSON file. And we're going to call that staticwebapp.config.json. And we're just going to bring a snippet in here. Now, this does a couple of things. One thing that this does is say that for my API authentication test, and when you rename something, rename it everywhere. When I go to auth test, only a super user is allowed to go to auth test. Auth test 2, anybody who's authenticated can go to that. I also have one for the counter because that's from a different demo that I give. This is more to point out that you can block routes to your client inside of this file as well. But honestly, I wouldn't, because once your SPA has been loaded in the browser, it never goes back to the static web app. So people can still get to where they need to go. Make sure that in your SPA, you have the right authorized views to stop people going to bad places. I've also got this last one in there. You saw me type in that URL, .auth/login/GitHub. Well, say I don't want people to log in with a particular login provider. I can add a route which says, this route goes to 404. So now you can no longer log into my app using AAD. Finally, I've added a navigation fallback. And what that does is allow us to make sure that we can refresh the page and not get a file not found error. Because if I go to blog posts, that only exists in the browser. There's no file on the website called blog posts. It just gets made by the router inside of Blazor. If you hit F5 on a static web app, there's nothing to point you to the right place. So this will do that for you. So let us now push this up to GitHub 2. So add auth. And with a little bit of luck, I've got just enough time left that this will build, deploy, go out, and everything's going to look awesome just before I stop talking. And of course, I need to pull then push because it's got the workflow file in there now. Yep, okay, that's all working as it should do. So if we go back to our site, I just said about adding that navigation fallback. I just want to demonstrate that for you. If we come through to blog posts and we hit F5, we get a 404 not found. Because like I say, blog post doesn't exist in the static web app. So we need to be able to fall back to index and let Blazor take care of that routing for us. We can see that the CI/CD has kicked off again. The last thing that I want to show you before we hopefully get everything working is custom domains. Because as much as our lively mushroom is an awesome domain name, it's not very memorable, especially with all of those letters in there. I want this to be my place on the web and my brand. So I want Stacy Clouds. Now, when you do this, you have to set some stuff up in a DNS provider. I'm not going to show you that because all DNS providers can do this differently. And it takes a bit of time to propagate through the net. But I do have a second static web app, and we are going to put this onto our own custom domain. So inside of the static web app, we have this custom domains page. And if we click on add and we go www.stacyclouds.com and hope that's the right one, when you add a custom domain, you have to put a CNAME record on your DNS, and you have to point that to your static web app. I've done this previously, and this will now add. It takes a couple of minutes for it to add, so this is going to like go around in circles for just a couple of minutes, and then hopefully it will be available. How are we doing with our deploy? That one's still going. In which case, there's one last thing that I can demonstrate while this is still going through that I have time for. And that is what you can do with pull requests for our applications. So I said, always make sure that you test your code inside of Azure. The Static Web App CLI is awesome, but always test inside of Azure. Thankfully, this workflow that we created will do that for you. When you create a pull request, it will also kick off that workflow. And when it kicks off that workflow, it will create a new staging environment for you that you can check to see that things are running as they should do. So here is what we have inside of our pull request. And actually, I believe it's on this page. When I wrote this demo, it was snowing outside. So I thought a wonderful change to the page would be to say, oh, the weather outside is frightful. Because our domain, which is still adding, unfortunately. Oh, that's so annoying. If we go to the Azure website and go to the same page, we can see this component demonstrates fetching data from the server. So this is how we can check our staging changes before we approve our pull request and push them through to production. Things you need to know about pull requests in static web apps. They are available to the world. If you have something which isn't supposed to go out to the world, make sure that you put, oh, that's interesting. This page has stopped working, unfortunately. I'll have to look at that one later. Make sure that you put a password on your staging app. This is something that you can do inside of your static web app. You can do that inside of the configuration setting. Let's open that in a new screen so it doesn't stop adding my site. Here we can have password protection. Now you can only have this on the standard, so you have to pay in order to have this. But if you have a standard hosting plan, if you have something which isn't supposed to be available on a staging environment, you can put a password on it to stop people being able to just go there should they stumble on the URL. Other nice one about this, if I merge this pull request and close it, it will clean up that staging environment for me. I don't need to do that myself. Now, can I finish my demos before I'm done? Yes. Okay, so I have my branch now. If I refresh this, I have my blog post. I don't have blog post. That's really interesting. What's broken? Come on, you should work. Oh, I forgot to check something in. I am so sorry, people. I made a mistake in my demo, even with my snippets that I was bringing across. What I wanted to show you here is that we can get things really secure. What I can do, if I come to SWA test.stacyclouds.dev, in the best Blue Peter experience, if I can remember the URL correctly, or not. Oh, Stacy. There we go. What we can do here, I can prove to you that if I now come into my API authentication test 2, we can see that I'm unauthorized. If I come back and come back again, and I log in, let's log in with Twitter. We can see that we go to Twitter, we log in, and now when I go to API authentication test, I get a forbidden because I'm only a standard user. And if I go to 2, I get my custom auth. Last one that I really want to do. No, unfortunately, Microsoft's taking too long. Sometimes adding a custom domain does take a bit of time. Okay, that was a very whirlwind tour of static web apps. And unfortunately, it wasn't quite the tour that I wanted at the end. But we have had 45 minutes. And in that 45 minutes, we've created an app with an API. We've pushed it out to a production site. We've seen how to add authentication, although it didn't work. I apologize for that one. We've had a look at how we can debug it. We've had a look at how to add a custom domain, which unfortunately sometimes takes more time than we would like. I hope that this has at least shown you some of the things that we can do and some of the things that are available inside of Azure Static Web Apps, and it's piqued your interest. If it has, then you can go to the MS Learn. The QR code is on the screen now, and you can learn for yourself. And I believe that in the private chat, we are going to be putting the links to the MS Learn path, the GitHub repo for the Static Web App CLI, and there's also one of my own CLI, own GitHub repos in there, so you can actually see authentication as it should be done and not as I did it in this demo. I apologize for the things that didn't work. I hope that you still enjoyed the talk, and I hope that you have a lot of fun over the coming 2 days with Global Azure Norway. Thank you so much.
Yeah, thank you. Thank you so much, Stacy, for a really great presentation. And I'm really impressed here by the way that you handled, there was some things that didn't go exactly as planned. I'm really impressed on how you actually handled that.
It's always a fun when you do technical demos. Sometimes things may just kind of like fall over on you. Yes. But I'm glad I had the backup for the authentication, because I really do think that glue in a static web app that joins it all together, that is what makes it such an awesome resource. Mm-hmm. And yeah, being able to show that you really can just put authentication in. You don't need to be an authentication expert. The resource itself takes care of it, and it's just an awesome thing to play with.
Yes. Yes, I believe we have a question here from the audience. So here we have a question from Torstein Nikolaisen. He says, what made you choose Blazor for your use? Did you consider any alternatives?
What made me choose Blazor is that although the company I work for, we build an Angular application and I can write Angular code, I'm a C# developer at heart, and I wanted to keep on using C#, and it builds so quickly. If you look at the amount of effort that it takes to build and run an Angular application versus a Blazor application, it is light years away in actually getting that built, tested, and uploaded. It takes minutes as opposed to a humongous amount of time, as it can do with some Angular apps. That said, if Angular is your thing, awesome, use it. It's I'm not really a how do you say that? It's not that I am Microsoft and I am C# and that is what you must use. You must use the tools that work for you, and Blazor worked for me when I played with it, so that's what I went with.
Yes. We also have here a comment from Hurtcakes that says, this was a very interesting session. Thank you so much for...
Yeah, you're welcome. I'm really pleased that you liked it. And again, I apologize for the issues at the end with the authentication. Again, I am going to look at what I did wrong so the authentication didn't work. And I'm going to put that on Twitter later, because I'd like you to know what I did wrong so that hopefully you can not do that in the future.
Yes. So Stacy, one final question here. So when can we see you next time?
I said the next time that I'm going to be giving this presentation, but a bit extended also with custom authentication, is at NDC next week in London. And you know what? I'm really going to make sure that I figure out what went wrong before then, because it would be nice if it works next time.
Yes. Yeah, well, thank you so much, Stacy. And yeah, we also have Another comment there.
Oh, we have Legos. Thank you. I love Lego. It's you can't have enough Lego in a home.
Yes. Yeah, thank you so much, Stacy, and hope to see you in person soon.
Yeah, absolutely. Have a good evening, and well, enjoy the rest of the conference, everybody. Bye-bye.
Thank you. So now, also would like to ask you to actually do a little bit of feedback here on our session. So we have Mentimeter, so we can put it up here. So if you scan this QR code over here, you come to our Mentimeter page, and there you can put in your feedback for the day, and we will appreciate very much. So having said that, let's switch back here. So then I hope you will join us for our next session that will be on the Azure Bastion. So we'll just stay tuned, and it will come up very soon.
I think this is a second session in Global Azure. There are some new people. Welcome. We are going to have the talk from Wim Matthyssen and Micha Wets about Azure Bastion. One does still not simply walk into my VNet. So without further ado, I give the word over to, I think also Wim first.
Yeah, I will take over the screen if I can. Let me see if I can take it over. So, I think Micha, normally my Azure portal should be showing. Yeah.
Yes.
Our slide deck. So, hello and welcome everyone. Thanks for joining. We hope you already enjoyed the first session of today from Stacy. Micha and my session is titled Azure Bastion. One does still not simply walk into my VNet. It's a version 2 of an older session Micha and myself delivered for the last time. I think it was somewhere in the beginning of last year. But in the meantime, Bastion has a lot of new features and capabilities, and that's why we created version 2 of this session. And we still think with the title and the picture, the topic in the theme used during our session will be rather clear. And we really hope that by the end of the session, everyone who's not yet using Azure Bastion will start using it. Before we start off, we want to thank Håkan, Christina, and everyone else involved with the Norwegian.net user group for setting up this Azure Global event focused in Norway. So let me go to the next slide. On the agenda today, the things we're talking about. First of all, we'll look at all the common VM administrative access methods, the different ways, the good and the bad ones on how you can connect to your Azure IaaS VMs before or next to Azure Bastion. Then we will talk about what Azure Bastion is and dig a little bit deeper in how you can deploy, configure, automate, and of course use it. And before closing off, if we still have some time, hopefully for a Q&A, would love to answer any of your questions, or we can just leave it to Gandalf, of course, but probably he wouldn't answer anything. So let me also shortly introduce myself for the people who don't know me and Micha. So my name is Wim Matthyssen, and just like Micha, I live in Belgium, where I work as an Azure technical advisor at a company called Proximus. Community-wise, I'm a founding board member of a Belgian user group called MC2MC, which stands for Microsoft Cloud and Client Management Community. In that group, we mainly focus on Azure and Microsoft 365, but we also keep an eye on security, Hyper-V, and I think even the complete Windows Server landscape. Next to that, you can see I also have my own blog, https://wimmatthyssen.com. I'm also a Microsoft certified trainer in a Microsoft Azure MVP. And like you can see, like most professionals these days, I'm also on Twitter and LinkedIn. So if you ever want to reach out or just want to say hi, you can always contact me through my Twitter handle @Wim or LinkedIn, or to make it even a little bit simpler, you can simply scan the QR code at the bottom of the slide. And I think, Micha, you can introduce yourself.
Yes, good evening, good afternoon. My name is Micha Wets. As Wim said, we're located in Belgium, independent contractor. But my main focus, my main job is working at Connection, which is in the West Flanders, next to the sea. Awesome company where I'm a Azure solution architect and also ambassador regarding Azure solutions. I'm a Microsoft MVP on Azure Virtual Desktop, but I also focus on a lot of Azure services together with Wim, like the Azure Bastion service, like we do today. Also, proud member of the MC2MC user group in Belgium, where we do a lot of user group evenings, awesome sessions. So if you want to speak, don't forget to submit your sessions. The same as Wim, Twitter handle, websites, LinkedIn, always there if you have questions regarding Azure DevOps, automation, and especially AVD, which is still my favorite service.
Still.
Still my favorite service.
Okay. So after that being said, I think we can now focus on our first topic. So where we will look into the common VM administrative access methods. So as most of you will know, the easiest way, but also the least secure one to connect to an Azure VM is through the use of a public IP address, a PIP. In this way, you can connect to the VM through RDP or SSH, depending if the VM is a Linux or a Windows VM. You just need to associate a new or even existing PIP to your VM's network interface. And in the case you have an associated network security group, an NNUG to the subnet used by the VM, you just open a specific port with an inbound rule and you're on. But let us say, yeah, this way of connecting is okay when you're studying for an Azure exam, you need to test things out, or when you need to do a quick test in your own company's dev test subscription. But you should really never, we can't repeat this enough, use it in any Azure production environment to connect to any of your business critical or production VMs. And this because one or both of the management ports will still be widely opened on the internet. And in this way, your VM can easily be attacked by or breached by hackers or script kiddies, or like you can see on the slide, by orcs. Another way we see a lot still being used, is that you connect to your EAS VMs by placing them behind an Azure external load balancer. Instead of the VM, the load balancer then uses the PIP and then redirects the connection to the VMs or VM behind it. In Micha's and mine opinion, it's kind of security through obscurity, like they say, because one or both management ports will be still widely opened on the internet. Only now there's an external load balancer in front of it. And again, in our opinion, not a secure method to connect to any of your EAS VMs in any production, pre-prod, or even a QI environment. Because, like I already said, attackers mostly target those open management ports on those internet-facing VMs with port scans, brute force attacks, or DDoS attacks. And in case of, for example, such a successful brute force attack, an attacker can easily compromise the VM, and in this way establish a foothold into your environment from where they can do whatever hackers do or they want to do. So on this slide, you can clearly see that if you have opened up one or both management ports, is it RDP or is it SSH, it really doesn't matter. And you open the associated NNUG, you will see that in the name field, the rule name is preceded by a hazard triangle with an exclamation mark. Microsoft is simply telling you there that there's a security risk by opening these ports to the internet. And for example, if you use, and you in a good way, you should use Microsoft Defender for Cloud, after a short time, you will also receive a recommendation over there to look into this and to change it by, for example, using JIT or using Bastion or removing the PIP. So then, of course, a question we all need to ask ourselves is, how can we then securely connect to our VMs? Well, first of all, we can do it by using a site-to-site VPN or an express route. In this way, you can connect from your on-premises network to the private IP address of the VM, so you don't need to use a PIP anymore. You can also use a point-to-site VPN to set up a secure connection to a VNet, mostly the hub VNet or a connectivity VNet. And this with the VPN, you can do it from your own computer, or if more security is required from your company sites or from your CISO, for example, you can do it from a privileged access workstation or a PAO. So these days, a point-to-site VPN supports certificate-based certification, where you can, for example, use the self-signed certificates. When you set this up, you simply need to specify an address pool, best in the 172 range. As tunnel type, you then select IKV2 and OpenVPN. you specify your Azure certificate under the authentication type, and then you upload the publicly of the root certificate to Azure. On the client device you want to use, you then install the client certificate, and then you download the VPN client from over here. You unzip the package, and under the AMD 64 folder, you find an executable you can run. And when you run that successfully, you then only need to connect. Let me click. And if you want to set up, I already wrote some blog posts about it. In one of them, through Azure PowerShell, I generate your root certificate and your client certificate. And in the other one, also through PowerShell, I configured the complete setup. So it will upload the root certificate and so on and so on. So with 2 simple scripts, you can easily set this up from your own PC, for example. Then next to Azure certificate authentication, you can also use Radius. But like you can see on this slide, you can also use Azure AD authentication with your point-to-site VPN. The biggest difference between when you use a certificate is that you need to specify the tunnel type. You need to specify OpenVPN. And as authentication type, you should specify Azure Active Directory. You need to fill in your tenant, audience, and your issuer. And then once again, you simply download the VPN client from over here. And then you run, you go to the Microsoft Store, you look up the Azure VPN client, you simply install it from over there. So we don't need to do anything else. And then you, after you download the VPN client from over here, you unzip that specific package, and you create a new connection with the plus button at the bottom, and you look into that extracted package, you look into the Azure VPN config XML file, you upload it, and then you simply open your VPN client, and you can connect in a secure way to your Azure environment. So next to those ways to connect, there's also another resource Micha and myself still see being a lot used into customer environments, and that's a Jumpbox or a Jump Host, or a Jump server, like some people like to name it. A Jumpbox is an IaaS service which is used to access and manage all other VMs in your environment. Mostly it's deployed in a separate security zone, management hub or a subnet. Yeah, of course, if you use the hub-spoke model, and you kind of jump off from that VM to all your other VMs when you manage them, when you want to manage them. To allow access from the internet, this VM also uses a pip, and sometimes it's even deployed as a small Linux VM. But once again, it's yet another resource for you to keep updated, a resource that you need to back up, and that you need to troubleshoot whenever it fails. And if you want to foresee high availability, you should also have at least 2 jump boxes deployed. So this will cost a little bit more. So if you're in your environment still using such a jump box and you have an associated pip to your NIC, there is a way to secure this. And to better protect this, and that's with the use of just-in-time VM access, or JIT. For people who don't know it, JIT enables you to lock down your VMs at the network level by simply blocking all inbound traffic to specific management ports like RDP or SSH. And in the meantime, it also limits the amount of time that those management ports are open to people with a maximum, I think it's still of 24 hours. And good to know is that JIT is available when you use the Microsoft Defender for Cloud with the Microsoft for Server Plan 2. Yeah, all those names just changed, so keep that one also in mind. So we just need to enable it, but maybe it's better I shortly demo it. Micha, I think my portal should be showing now.
Yes, it's visible.
So if you want to enable JIT or use it, you just go to your Microsoft Defender for Cloud. And then under cloud security, under workload protections, you can click on it. It will take some time. You scroll down down to the bottom, and there you can find just-in-time VM access. Over here, you can see that I already have 3 VMs configured for JIT. You can see for this specific VM, there was also 1 request already made. And for this VM, there already were 2 requests made. If you ever want to edit specific settings for that specific VM, you can simply click on Edit. You can change the ports, you can delete it, you can add extra ports, you can change the time, and so on and so on. You can also see all VMs that are not yet configured for JIT. And from this page, you can also, if you do it through the portal, normally you do it through automation, but if you want to do it through the portal, just click on it, you enable it, and so on and so on. If you then want to use JIT, let me go to my virtual machines. I think I can do it on this one. So I have a test VM. You can see there's a public IP address on that one. You simply click on the connect. You click on RDP because in this case it's a Windows VM. You can see public IP address port 3389, and then you can see this VM has a JIT access policy in place. You simply click on request access. This will take some time, and in the back it will process it. And it will open a specific inbound rule on the NSG, allowing 3389 to be the protocol to be used. So if you give it a minute or 2 minutes, you simply can download the RDP file. Let me open the file. Probably it will not already be in place. You then simply click on connect. Let me see if it's already configured in the back. It's running. It's probably still too early. Normally it takes around 2 minutes, I think. So let me try that one again. Running. It's still taking, still not there. And there it is. So you can see I have my username, and I can now simply type in my super secret password. You can see for the P, let me click on yes, and there it is. And you can also see I'm connected through my public IP address. So Micha, with this demo, I think it's up to you now.
Yes. I think my screen should already be visible. Yeah, perfect.
Yeah, it's there. So I think I'm showing now.
Yeah, Micha is
Go.
yes,
Yeah, there it is.
yeah.
I was starting to
It was a strange slide deck with my face on there.
and then it Chrome just died.
Yeah, if I need to share, just say that.
No, I think it should be fine. Okay. So enough talk about how we also can connect. Let's talk about Azure Bastion. So what is Azure Bastion? This is the definition from Microsoft. So Microsoft does explain that it is a PaaS service, and it gives you the possibility to connect to your virtual machines directly from the Azure portal using SSL or HTTPS, as we all know it. But let's take a look and let's present you an overview. So it is indeed a PaaS service, a jump box as a service, as Wim and myself like to call it. And it is provisioned inside your VNet, inside your virtual network on Azure. It gives you a secure RDP or SSH connection. So it is both RDP and SSH connectivity directly from in the Azure portal. The big advantage is you don't need to assign any public IPs to your virtual machines. It uses a public IP for the Bastion, and that's about it. That's all you need, only a public IP for the Bastion host, but no IPs, public IPs for your virtual machines. Not even load balancers, nothing like that. It's only the Bastion host. You don't need additional software installed, so no special clients on your own client device. It's just within the Azure portal. Underneath, as you probably already know, it is a VM scale set. So it's a PaaS service. Microsoft does provision a VM scale set for you. So it does have the option to scale depending on the requirements that you have for your Bastion service. Because you don't add public IPs to your session hosts, it also means that you are not facing any attacks to your virtual machine. I did a test, I think it was last week, where I created a virtual machine. I installed a SFTP service, opened up a port 22 to it, and within 1 hour, I already had around 20-30 hits on my SFTP service, all connecting as root, of course. But that's just within 1 hour. So if you think about it, if you keep it open using RDP or SSH, you definitely get hits on your virtual machine. So it is always dangerous to just simply put it open in the air. As it also states, you're not affected by any port scanning because no public IP, no exploits possible. So if somebody would find a bug in Windows, which is highly unlikely, I think, Wim. Bugs in Windows, or even malware targeting, you're just not in danger because you're protected by not assigning public IP addresses to your virtual machines. When we first presented our session, there was only one SKU. Now Microsoft made 2 SKUs for Azure Bastion. They added some services and put it into the standard SKU. By default, as I said, it enables you to connect to Windows or Linux virtual machines without any issues, even in the basic SKU. Linux using SSH to your Windows virtual machine using RDP, of course. Also, a nice feature, which is kind of new, is the audio output. So if you want to use audio from within your virtual machine, you can simply use it, and you can even hear it on your local device. So it is available in the basic SKU. If you compare basic to the standard SKU, you will see if you want to enable host scaling, then you need to go to the standard SKU. So if you want to have the possibility to scale your Azure Bastion depending on the requirements and the sessions, of course, then you need to look at the standard SKU. Also, if you want to use your native client, so without actually using the Azure portal, you have to go to look at the standard SKU. So then you can use a native RDP or SSH client on your device and connect to your virtual machine. Also, within the basic and standard, you have clipboard redirection, so you can copy paste. But if you want to upload or download files to your session host or to your virtual machine, then you have to look at the standard SKU that's available right now in the standard SKU. For disabling copy paste, so you can indeed disable copy paste into the VM if for some security reasons. Then you also need the standard SKU. I forgot to click, of course. How does it work? How does Azure Bastion actually work? So as I said, it is provisioned inside your virtual network. As you can see, it gets injected as a managed appliance in your VNet. Only HTTPS, so port 443, needs to be exposed to the internet on your NSG, and that's the only port that needs to be available. From the Bastion hosts, you need to allow 3389 or 22, of course, because the Bastion host itself needs to be able to connect to your virtual machines. But that's only from the Bastion host, not from the internet. It's only the Bastion host that needs to be able to connect to your virtual machines. And as you can see, no public IPs need to be assigned to your virtual machine. So only on the Bastion host. At the beginning, at our first session, there was a limitation for Bastion. Bastion needed to be deployed within every VNet. So if you would have a hub-spoke model and you wanted to use Azure Bastion, then you had to deploy Azure Bastion in each and every single VNet. Luckily, after a few months, Microsoft did enable the support for VNet peering. So in the demo, you will also see that I have VNet peering, so a hub-spoke model, and it does work without any issues. And this is also the demo or the presentation from a typical hub-spoke model. So we have our hub VNet, which is connected to the internet, public IP address attached to it. Within that hub, we deploy our Bastion hosts. And within our spoke VNets, we have our virtual machines, our session hosts, or our application service, or whatever. And they just peer to the hub. And then from within the Bastion, we are still able to connect. If you want to use the native client, so within the standards queue, it is possible. You have to use Azure CLI to set up the connection. So it all states you need the standards queue, the basics queue. It is possible in the portal. If you want to use the native client, you have to use the standards queue from Azure Bastion. Depending on your connection type and the client, you can also upload and download files, which is an awesome feature. And as it states over here, 2 ways of connecting, either using the native client on your Windows PC, or you can use a non-Windows PC, because there are a lot of non-Windows users. Like Linux, you can use the AZ Network Bastion tunnel command. So if you install Azure CLI, then you can use that CLI command to connect to your virtual machine, but through your Bastion deployment. Some use cases, why you want to use Azure Bastion. If you don't have, as Wim described, a site-to-site, point-to-site express route from your on-premise network, then you don't have that secure connection, then you need a solution like Azure Bastion, of course. If a jump box does not meet the requirements, the security requirements, like 3389 is not allowed, it is too expensive, things like that, then you can't use a jump box. If there is a hard requirement from within the company that only HTTPS can be allowed inbound into your environment, then you can't use the RDP protocol or the SSH protocol. So you have to find a solution for using HTTPS. Sometimes it's also important that you are not allowed to have any management on your environment. So you need to use a PaaS or SaaS service. Then you can't use a jump box because that's a virtual machine. You need to do updates, things like that. So that's out of the option. So you need to use a PaaS service. Also, as Wim will demo in his demos as well, there are multiple ways to deploy Bastion, and it makes you gives you the possibility to easily deploy and remove the Bastion host or the Bastion service. So if you want to have a solution that is easily deployable but also easily removable, then you need to look at Azure Bastion. Also, the temporary access to the VM with JIT. Wim already showed you JIT access to a VM which is exposed using public IP, but still with JIT in front of it. You can also use JIT with Bastion, but I think Wim will be pleased to show you that one as well. Pricing, which is also important, of course. This is the pricing from a basic Azure Bastion host, a Bastion service within West Europe. Comparing to a standard costs about 70 euros per month more. So you really need to look at which services or which features that you want. You also need to take into account the traffic, because as all services in Azure, you need to pay for the outbound data. So really take a look at the outbound data that will be used by the Azure Bastion host. And if you use more than 500 terabytes, you really need to contact Azure Sales.
I still need to find any customer using over those terabytes.
Also, if you go for the standard SKU and you add additional scale units, you also have to take into account that you pay for those extra scale units. So this is the pricing at the moment. You really have to take into account about those scale units. And of course, depending on the region, it could be a different zone. The pricing was for zone 1. So you really need to check those pricings if you want to use it. Enough talking. Let's show you how it works. As I said, I did a small, simple deployment where we have a typical hub-spoke model. This is my hub. It's located in West Europe. As you can see over here, we have one Windows virtual machine, which is located in France Central. It's peered to my hub VNet, and we have one VNet also located in West Europe, but it contains a Linux VM. But let's see how we can connect. Let's start with the Windows VM. If we open up the portal, we can see our Bastion hosts. Bastion has a public IP, our 3 VNets, and our 2 virtual machines. No public IP assigned to the virtual machines. It's only on our Bastion host. If we would do the same as Wim did before in this demo, and we would go for the RDP, then you would see that we only have a private IP. This is ideal if you have a site-to-site, but in our use case, it would not work because we are not connected. So that's why we have the third option. You can do the same from here, connect using Bastion, and you instantly jump to the left section over here at the operations Bastion. Because my VM is indeed peered to my hub, and my hub does contain a Bastion host, it does detect the Bastion, and it says, okay, we're going to use this Bastion host, and it is indeed succeeded, so we can use it. We type in username and password. A good tip from Wim as well, if you want to change your keyboard layout, this is not something that many people know, you can still change it over here. So Wim pointed it out that if you want to change the keyboard language, you can still do it before you connect. And then, for example, if you use a Belgium-French keyboard, you can still select French-Belgium and connect to it. So type in username, password, hit connect, and you will see that a new tab is opening, and we are connecting to our Windows VM, and we're in. We're in with our username, password, and we can simply start using our management or do our management on our virtual machine. We can do all management that we want. It's kind of the same as we would RDP into our session host, but also the experience, if you want to look at it, it's kind of like RDPing into your virtual machine. This is a Windows PC. The same can be done using a Linux virtual machine. If we connect to our Linux VM, we say, okay, let's use Azure Bastion. We type in username, and depending on your deployment, it can be a password, and as I say, a private key. It can be even a private key from a local file, but also a nice feature. If you put in your private key in your key vault, you can even select this one and select the key vault and the secret that you want to use. So you don't even need to remember the password if you want to connect to your VM. Let me quickly connect to show you. Now, I'm not a Linux guy. I'm not that deep into Linux. But what I always do if I connect to a Linux and do a demo, it's using curl. And then, of course, if people know this, the parrot.live, which is the awesome dancing parrot website. This is for managing your VM. If you want to look at your Bastion, so if we click on the Bastion hosts, you will see that we have 2 sessions. You see which user is connected, which is the target resource group, also the target hostname, of course, when it started. But you can also stop a session. So if you want to stop a session, you simply click on the 3 dots and hit delete, and it will terminate the session. You can also right-click and hit delete, and you will see that our session is indeed disconnected, and you will get this message. Before we go back to Wim, there's one thing that still is important. So you have the sessions over here. There is the option to switch between SKUs. So you can, if you are using basic, you can still switch to standard. You can't go back, but there is an option. If you are in the basic, you can still go to the standard SKU. And I think that's about it for my demo. And then we can jump back to you, Wim.
Well, let me see if I can share my screen again. So my portal should be showing now. Let me take my slide deck again. Is there? So, like always, I love seeing that parrot dancing, to be honest. But for now, let us in the way how to deploy and configure Bastion. So, first of all, like with every new deployment in Azure, it's best to check if the resource or service, in this case Azure Bastion, is available in your region or the region where you want to deploy and use it. Like Micha already said, there are different prices depending on the region where you're in. There are still some regions, Azure regions, where the Azure feature service isn't available. Next to that, hopefully all of you have some kind of Azure governance strategy in place or use a specific Azure governance plan which you need to follow. So one, for example, for the naming of the Bastion host and all related resources like the PIP and the resource group, but also for tagging convention need to apply. By the way, like you can see on the screen, a good tag to use in combination with Azure Bastion is, for example, one that describes the VNet, because in this way you can easily find in which VNet that Bastion host is deployed. And most of the time it will be in some kind of hub VNet if you work in the hub-spoke model like most customers do. And then before you start deploying your Bastion host, you can already create the specific subnet in your VNet. This subnet always need to have the name Azure Bastion subnet and should at least be, since standard came in place, be a /26 or larger. A thing you should also check is that you have the necessary address space available in your VNet, because a thing we see a lot is that a VNet, the complete address space is already used by other subnets. People want to start Azure Bastion and then they start the deployment, but that specific space isn't available anymore in the VNet, and you need to create a new one, peer that one again, and so on and so on. If you already deployed the subnet in advance and you want to better protect it via a network security group, then you should also have to be sure that all the necessary inbound and outbound security rules are in place to allow the necessary access to for Bastion to connect to the VMs, but also for Bastion to talk to the data plane and the control plane. Otherwise, your Bastion deployment will fail. Also keep in mind that if you're using Azure Firewall, like probably some people will be using, or any other network virtual appliance, is it a Fortinet or whatever, it doesn't matter. You don't associate the Azure Bastion subnet in the route table. Otherwise, you will end up with blocking all the necessary traffic required for Azure Bastion to work. Next to that, oh, I was already clicking. Let me go back. Next to that, you should also not associate or combine Azure Bastion with an Azure Private DNS zone because it's still not supported at the moment. And when you start deploying, there's also one specific resource Bastion requires, and that's a public IP. It needs to be a static public IP, so it must be a standard public IP SKU. And then you can simply start deploying Bastion. You can do it by using the Azure portal. You can using Azure PowerShell, Azure CLI, ARM, or Biceps, or even Terraform these days. You can do it with whatever language you want to use or whatever way you want to do it. Like I just said on the previous slide, to harden the Azure Bastion subnet, you can use an NNUG, and this to only allow the necessary inbound and outbound traffic. So like you can see on the screen, there are quite a lot of inbound and of outbound rules required. Most of them to allow ingress traffic to your Azure Bastion to the control and data plane, but also to allow ingress traffic, for example, from an Azure load balancer. Next to those inbound rules, you also have some required outbound rules. Two of them to allow the egress traffic to target the VMs via RDP or SSH, and the other ones to allow the egress traffic to the Azure Bastion data plane, and also all other communication required, so like communication to public endpoints in Azure. And one thing I also want to mention is when I put in the necessary rules, I always close off with a 900 number. This 900 rule, if it's outbound or outbound, will always block all other traffic. And in this way, the default rules that are in place, which you can't delete in an NNUG, will be blocked, because everything stops at rule 900 and it will not go any further to rule 60,500 and so on and so on. So just a tip we want to give. And if you put some energy in place and not all the rules are in place, or you deleted a specific rule, you can see, you will get an error. So you will not be able to save the subnet anymore, or you won't be able to delete the security rule. If it's inbound or outbound, it really doesn't matter. And as an Azure admin these days, from time to time, you also need to be able to troubleshoot your Azure services. And just like most Azure services, you can also use log diagnostics for Azure Bastion. So when users connect to workloads using Azure Bastion, Bastion can log diagnostics of the remote sessions, and you can then use those diagnostics to view which users connect to which workloads, at what time, and from where, and so on and so on. In order to use diagnostics, you just need to enable diagnostics logs. So you go to your Bastion host, under monitoring, you click on diagnostic settings. You can see I already have a diagnostic setting in place, but if there's not one, you add one. In my case, I just click on edit settings, and then I specify which one I want to use. Mostly by automation, I choose the categories, Bastion audit logs. I also select all metrics, and then in most cases, customers will send that specific data to a log analytics workspace, which in my case is located in a different subscription underneath my platform management group. So that's how you set it up. But you can also enable it quite easy through automation. So like Micha already said, what about JIT VM access? So you can simply combine this. The only thing you should be aware of, that you still need to request the access first under the RDP tab or under the SSH tab. Then you need to wait until the request is approved. And when the request is approved, you then simply click on the Bastion button and you log on with your username and password and specify your specific keyboard, for example, if it's a Windows VM. So it's quite a different process, and hopefully JIT will be integrated in the Bastion blade also. But it's a request that's already going on for, I think it's almost 2 years. Of course, there are also some RBAC rules which you can apply or which are required when connecting to Azure Bastion. All of them, you should at least have reader roles. So you should have the reader role on the VM you want to target, on the NIC with the private IP of the VM, and also you need to have a reader role on the Azure Bastion resource itself. And if you have peer networks, you should also have the reader role on the VNet being used. Good to know, and something we also want to mention is that next to connecting to your Windows and Linux VMs, which Micha demoed quite really nice, you can also use Bastion to connect to all VMs in a VM scale set. And even if there's some developers listening, probably they are, you can also use it in combination with DevTest Lab VMs. Also to know is that at the moment you can have around, I think it's still 25 concurrent RDP connections and around 50 SSH connections. But keep in mind that that number can really depend on the number of already ongoing RDP or SSH sessions. These days, you can also use Kerberos authentication in combination with Azure Bastion. You can use it in combination with the basic and the standard queue. It's quite easy to set up. If you already have a hub-spoke network, hub-spoke setup in place, you just have to have an Azure IaaS domain controller in place, which has also the DNS role. Those specific IP addresses of the DNS you need to place in the VNet settings under the DNS. So they're pointing to your domain controllers for seeing DNS. And then you simply enable Kerberos under the Bastion blade. It's still in preview, but it works really good, to be honest. And so by default, for the authentication to a Windows VM, Bastion in the back still uses NTLM. But by enabling this, you start using Kerberos, which is much more secure for connecting through RDP to VMs. Of course, there is a way to automate all of this. You can simply deploy Bastion through the portal, go with every click a step further, connect the VNet, and so on and so on. But to make it a lot easier, I wrote an Azure Bastion deployment script, which does almost everything. It's basically see if the Azure Bastion resource group is available. If it's not available, it will create it. It will set as NSG with all the inbound and outbound rules on the Azure Bastion subnet. If the Azure Bastion subnet is not in place in a specified VNet, it will also create it. It will create a necessary pip, also apply all tags. It starts the Bastion deployment, which, by the way, can take up to 10 minutes, depending if you're deploying a basic one or a standard one. Well, the standard one can take a little bit longer. It also directly set all diagnostics, and in the end, it even locks the resource group in which the Bastion host is deployed. But also good to know is that there are some community solutions which can, Micha showed you the pricing of Azure Bastion, which is, if you keep it running for 730 hours, so for a complete month, for some smaller companies can be pricey. For a basic one, you already pay around 131 euros. So if you want to drop those costs, and there are some good community solutions like an Azure Logic app written by Parveen Singh. The primary purpose of this Logic app is to save on the cost, so you can deploy the Bastion host, all other required resources are already in place, but only the Bastion host will be deployed at the moment you require it, and you can drop it afterwards. So it's a good way. But there is even a nicer way to do it, so you don't need to do anything, and that's by using the Azure function written by Ben Hummerston. And by this, it will the Azure Bastion host will be automatically deployed during business hours. So you start in the morning at, let us say, 8:30 p.m. Bastion host will be deployed, and it will live until the end of the day. So maybe you close off at 6 p.m. It will kill off the Bastion host. So you're only paying during business hours for, let us say, 8 hours. But maybe let me quickly show it. So if you want to use my deployment script, I think the links are in place. You can simply go to my GitHub. I have an Azure Bastion repository, and you can find the script over here. On my blog, I also wrote a complete blog post about it with all different steps explained with tons of screenshots. So if you ever want to do it in a quick way, and you don't want to mess around with all those different required resources, you can simply run this script, and it will deploy your Bastion host with all specified tags in place. It will, I now think it's the basic queue as deployed, because I think most people will use the basic queue. If you want to change it afterwards, you can also, or just change it in the script, change the variable, and deploy the standard one. You can see I also have copy and paste in place. I have a Kerberos in place. I have native client support and so on. And I also have the diagnostic settings automatically configured and so on. So I think with this being said, Micha, we can conclude our session. I think it's time. We're right on time. So I don't know if anybody has any question for us, or did you see any in the chat?
I didn't see any in the comments.
There's no questions yet, and you answered all of mine.
The easiest way, just run the script. It will save you a lot of time, I think. There are not a lot of Bastion deployment scripts. I'm using that specific Azure function at the moment, and I'm rewriting it so it's using my script, which does all the steps with the deployment. So probably in one of the following weeks, there will be another blog post and something in my GitHub repository available, which deploys it with the Azure function in place at once. So, and it will probably save you, half of the money you pay for it.
Nice.
Okay.
Very interesting session. Thank you. The comments. I can agree on that. So there's a QR code. Let's see, that way. And also the link should be in the chat for the Mentimeter. It's very quick to answer, so please do that. Give some feedback. And if there's no questions, I think we could just get ready for the next session that starts in about 7 minutes.
That means we did a good job.
Yeah.
I put my turbo on the last ones.
Let's see.
Hello everyone, my name is Lars and I'm part of the NNUG board. I would like to welcome Mattias Lögdberg. He's a solution architect at DevOps Solution. He specializes in Azure mostly, and he's done a lot of public speaking, has a great blog, and that has led to him becoming a MVP. So I'm really looking forward to his talk today about managed identity. And over to you, Mattias.
Thank you, Lars. That's good. Yeah, today we're going to talk about managed identities and how we came here. So managed identities is something that Microsoft has been boosting quite a lot during last fall, I would say. It really came... we can say that you guys might know the Cosmos incident that happened last summer, where they accidentally leaked out more or less any connection to any Cosmos, or any, what do you call it, key to Cosmos, account key. So that increased their investment in managed identity, I think, heavily, and also for us other ones. So that's one of the things that managed identities is good for. It's good for us making sure that we can skip these static keys. So let's jump into this, and let's see where my PowerPoint is. There we go. I won't use many slides. You have seen me before, know that I'm not using that, but this is me, and you can reach me on social medias or find my blog or LinkedIn or GitHub. I have some repositories there. Today we will talk about managed identities. I did a short introduction to this, a short background, but we will do this. And well, this is my PowerPoint. Then I'm out. So first of all, we need to have a understanding of what managed identities is. So let's just use my favorite tool, the whiteboard, and let's remove this man over here. So when we talk about managed identities in Azure, I want to try to explain it a little bit like this. So if we have a line over here, and on top of this one, we have Azure AD, and down here we have Azure. So in this area, we are creating this down below area. We can create resources. So in this case, we can create let's say we create a function. So that function is live, and you know from experience that you can call it from Postman or from other services just to get data from it or to it. So that instance is live and living in Azure in a data center somewhere. And what managed identities is that we can assign an identity, which is a virtual user for my function, just like me. So if you take me, for instance, I'm the man, I'm the guy over here. So I have a virtual copy of me, which is Mattias in Azure AD. And that we can also create for the function. So we can actually create the identity, the function identity. On the same way as I have an identity in AD. This gives us quite a lot of flexibility. One is that we can actually grant access to that identity, which that service is using, on the same way as you can grant access to my user as Mattias. So let's just say that we have we're going to use this later on, a service bus namespace over here. I want to have access to this in a contributor, as you might know, because I want to be able to manage it. I want to be able to create queues. I want to be able to create topics and subscriptions and so forth, or manage the service bus. But for my identity on the function, I can actually create a way of saying that I'm a sender. And then I can push data into my service bus. So this can be done in the same way as you are for you and me. So this is really nice, and it helps with a lot of questions, I would say, in daily basis. It helps with security. It helps with ease of knowing who has access to what. Because the normal way would be that this function has using a static key to access the service bus. And well, moving this into AD, we get a lot more insight into who has access and what privileges they actually have. So this is the basic on managed identities, and there's two different types of identities. It's user managed identities, which is an identity that can be shared among a lot of resources, multiple resources, I would say, and that can be created on forehand and actually managed and assign permissions and so forth before the service is live. And then you also have the system assigned server identity, which will be created at the same time as your service. So in this case, when I create the function, I will actually create identity at the same time. This gives a one-to-one identity for the function, and also the usage of these is a little bit dependent on how you want it and the permissions, because permissions is quite important on this area as well, because normally if I would have been a contributor, I would be able to collect my static key, and that would be a good one. But if I'm just a contributor, I won't be able to actually assign permissions to my function app. So there is a little bit difference. The main two big problems I think that this actually solves is static keys. And also, as you all know, when I'm as a developer is doing something, I will log in and I will actually copy the connection string for my service, and then I will connect. And that connection string will be stored on my computer. So in the end of the day, I actually have that key on my computer, and that's not so good. Meanwhile, with managed identities, it would be my identity and my assigned login on Azure that would be granting these permissions. So static keys, and also a little bit on who's using what. Who is using. And no wandering keys. And no wandering keys, I would say, is Good one for me as a consultant, because then I know that I can't leak away keys or something like that. I'm just gonna, when they kill my AD account, I have no access to anything anymore, and that's good. And that's actually really good for my sake, at least. So this is a bit of background, and as I mentioned in the beginning, a lot of investment has happened to this during the last fall, and you can see that still there is a lot of preview on this. We will look into that as well, but I would say that the Cosmos incident last summer really opened the eyes for this, because then it became really important to have a good what do you call it? It's called a key rolling regeneration of keys. And let's just be honest, that's not we're not always that good on that. We're good on it when we have high demands on it, but if we don't have any high demands on it, we tend to forget that we need to roll keys. So this is a good way to actually don't needing to have that problem anymore. So let's just see. Let's just take a short step and let's just create. I will actually use a logic app, but let's just create a service, an instance, and then we will create our identity. And we will then look into how permissions will look like. There we go. So let's jump into the Azure portal. So in my demo resource group, which we'll use right now, I have created a logic app. I have a bunch of services here that we will use today. We will start in the logic app. So I pre-created this one. Let's just verify that I actually created an identity on this, because I'm not 100% sure right now. But let's just go ahead and do that. Let's go ahead and create an identity. Oh, we didn't. Let's see. So there we go, save. Yes. So now we create an identity for this logic app. And if we want to look into how this is looking like, we can actually go into Azure AD. We can then go into enterprise applications. And on enterprise applications, we can actually go ahead and switch the application type and say manage identities. And then just press apply. And then we can actually see our int001 read message. We should be able to find it. There we go. Here's our int001 read message. So this is actually the identity in Azure AD that is connected to my logic app. And we can, see what permissions we have and so forth. So now that we have an identity, we can actually assign permissions. And let's go to our, we want to read messages from a service bus right now. That's what we want to do. So we have a service bus, role-based access sample. And as I mentioned, normally you would go ahead into this shared access policy and you would go and collect one of these keys and use that. If I would have taken the publisher, for instance, I can just go in and get the primary key and secondary key or copy the connection string, which would be a valid solution. But now I want to use my newly created managed identity or my newly created identity from my logic app. So then I go to access control, just as I would have done for a normal user. So then we go to role assignment and we just browse it. And there we go. We don't have that much. We have a service bus data owner, that's me. And this is a special role, and this makes me able to actually use my user to publish and read messages from the service bus. But I want to, I actually forgot something. I'm going to do a reader role. Reader role is a little bit, so the data owner is one, but if I'm going to go ahead and do a reader role, wrong button. I actually need to go on my queue. Because I'm going to read from a queue, so I actually need to go into my queue. And I need to put the permissions on this queue, because if I'm not doing that, it's not going to be able to trigger on it, actually. This is valid for both logic apps and functions, and I guess other services as well. And so if I go into access control, I will then add a rule assignment on my queue. Again, it's important to do it on the specific queue because that's where we are. And there are a few special roles for Azure Service Bus. So we have the data owner, which would give me a publish and read, read and so forth. Both of them, receiver, sender, sorry. It will give me both the receiver and the sender role. But if I want to be, I can just pick the receiver role. Then I know that my identity will only be able to receive messages. And that's the only thing I wanted to do. So let's just pick receiver. And when I want to assign the role, I pick the manage identity. And I click members. And I need to go ahead and say that I want to assign this to a logic app. And then filter out to my logic apps that I have. And I want to have this read messages. Read message. There we go. Select and review and assign. Review. And now we are assigning it. So right now we will see that we have a reader role for my read messages down here. So this resource I can go ahead and read messages. If I then go back to my, let's go back to my logic app again. I can now create a receiver. So let's go ahead and do that. Let's pick the receive message from Service Bus. When a message is received on a Service Bus queue. Perfect. And now I need to connect. And this is the important part because when I do sign in, the normal way would be to get the access key and the connection string, which I showed you. But I don't want to do that because I want to do this logic apps manage identity. This is still in preview, just so you know. And I just do it to roll back. And now I need to have the namespace endpoint. So if I go back to my sample, I want to have this host name. The annoying part is that I actually need to add something to this. So I actually need to add sb : / just to make sure that I had 2 slashes. Yes, I need to have that. And if I'm skipping this, this will fail. And yeah, you have to do that. I would actually like to have that on this side, but yeah, we just need to remember that. So now I'm creating this, and perfect. It went green. Sounds good. And let's just have a pick the queue. Unautorized. Okay. Oh, maybe I just need to have, because I didn't give anything more than read. Let's just pick my queue and go ahead. And let's add a new step, add a compose. And then we can just get the content of the message. Let's just press save. And let's see if we have anything on the queue. Probably have, because I think I left some data on it. I hope. Let's just go ahead and take a sneak peek from the run history. And let's take refresh. There we go. We got a few of them. And the trigger history looks good. So let's go back. Let's pick this one. So we got a message. Oh, we got a base 64 message. I think that is, isn't it? Let's just fix that one. So we can read the message, much more fun though. Base 64 to string. That's what we want. And we want the content. There we go. There we go. So let's keep that for next time. But as you can see, I can now connect, and I didn't use any keys at all. I didn't use the connection string. I just used my identity, which I assigned. So this is how we can do this in Azure, and it's quite a simple, seeing this in Azure. But as a developer, I also want to make sure that we have things. How does this affect me as a developer from my side? Well, we need to take into consideration that we are needing that role. As I mentioned, as I showed, we also need to have that role. And that's also the thing with it when doing this, that if I'm going to use identity, I can use this. I need to make sure that I have this role. Because then I can use my identity from a developer perspective. So let's just look in how that can see. So let's just have my service bus publisher. So let's start publishing messages. So I have a very simple function. I'm jumping to functions now because it's easier to debug locally. So if I'm going to go ahead and publish messages to my Logic app, I'm going to use this function. As I mentioned, very simple. I will just use a normal. I've created this and just added a service bus return statement on this one. So I use the connection to that. And I will just take the data that's sent in and I will publish that because the data return over here will be published on the queue. And if we go to local settings, I will use my role-based access, this key. So this is the shared access key. So let's just start with this. Let's just make sure that we got something working, right? So I need to use Postman in order for this to work. So let's bring Postman in and let's bring it a bit smaller on this smaller screen. There we go. And we have a service bus local. Sounds good. Then we can close. See how this goes. Then we can close. I just need to wait for my debugging to start. It was a bit slow. Let's bring it in so we can see that it's working. So what I want to do now is just show you the static key version and go on to that and just make sure that we actually have something working. And what I hope to achieve is that we go ahead and into my Logic app and we will see a new run. That's my plan. Okay. There we go. And let's see if we got this one working. A bit slow. Now's the time for a good pause music or something, or a good joke. Oh, there we go. Now it's up. Let's press send. So I'm going to publish this message through my local function, my local debugged function, and we will see that it's the same message and it's executed and we get a 200 OK. And if we go up to our Logic app and we just force this to trigger, we can see that we get a new message. And let's see if my base 64 decoded thing works. We get a message. Let's crossing fingers. Yeah, that's it. There we go. So now we can see that I can publish messages. So I'm using role-based access for my Logic app, but I'm using the static key for me as a developer. So this is nice. This is a good way of starting. But let's just say that we got some requirement that we need to do this on my own. I need to do this on my machine. We can actually do that rather simple. So in Visual Studio, for instance, we can go ahead and go into options. Then we can go into something that is called Azure Service Authentication. So in this area, I can log in with my user, which I have done. So this is my user. And I can actually say that this is the user that we're going to use with Visual Studio when we are debugging. So that's good. I also need to update my connection. And I actually need to do this part. So as you can see from this one, they have the connection and it's called Service Bus Connection. So this is the important part. So this is actually showing me where to pick my, from standard. This will point to the connection string to my service bus. But when we use MSI for this, when we use manage identity, which would be my identity when I'm local, I actually need to do this in a little bit different way. I actually need to use a setting that is called service bus connection. The same thing, same start, but with 2 underscores, and then the fully qualified namespace. So this is the information needed. And that namespace is the same thing that we entered for logic apps when we did that connection. So then I can just go ahead and add this part, which is the same thing we had over there. Then I can just go ahead and let's just remove. Let's just cross out. There we go. So we did this little fix. I'm using the same connections, same connection parameters with my settings. I'm just adding these underscore fully qualified namespace. And I can then go ahead and say that this is my user who's going to use this. So when we connect now, when we try to connect to the service bus, publishing messages, it will be my own user who's doing this. So as I mentioned earlier about leaking keys, so instead of me having all of these keys stored on my computer just to make sure that I can do debugging and so forth, I now am using my AD account, and therefore I don't have any connection there. So as soon as an administrator goes in and say, hey, Mattias is not going to have access to this anymore and removes it, I'm not going to be able to publish any more messages or read messages for that part. So this is a good way of keeping your good health on, what do you call it, a good cleanup on where all the connection points are. So let's hope this is working out. Let me see. There we go. And MSI message. Let's use that. We can see that we do this. And let's cross fingers for this to work. And there we go. We can see we got the post message, we got the 200 OK, which means that I was able to connect. And as you can see, there's no connection string anymore. So if we go up here and take refresh, we might see a new one. No, we might want to need to force the trigger again, just to make sure. Come on, there we go. Or, no, skipped. Come on, run again. Didn't I get the message? $200 OK. Again, let's try it again. Oh, that wasn't the plan. Sorry. And let's go back to this one. And let's take a refresh again. Runtime seems to say it's okay, and let's just go ahead and see if we got a message on the queue. No active messages. Interesting. My demo is not working with me. That's terribly sad. Let's see if I change something. I actually have this down here, and or if it's something else. Let's see my queue. I know my queue. Very interesting. Well, you always have to have some demos that's not working. So yeah, let's see if this works out for me. But let's not stop here. Yeah, interesting. Anyway, so take this another step. We would actually be able to say that. So now I've shown you, and I showed you that it was actually working when I used the static keys. But I can actually, on my service bus, I can actually go ahead and say, I can actually show you. So on top of the overview, we actually have, since some time back, we have a new part over here which is called local authentication, which is enabled. And if I would say that this is disabled and I press OK, there's no way of publishing messages anymore on this Service Bus namespace, or read messages at that part, using that local key. So anything you go from the shared access policies will not work anymore. You have to use MSI in order to connect to this namespace. So this makes it easy to block unwanted traffic and make sure that everyone is using local authentication. And I'm really interested in why we didn't get the messages. It annoys me. Yeah, well. I think you will have to believe me that this is working. And the strange part is that we didn't get an error. That's usually the case, that you get an error first. Let's see again. Let's just try this one again. Come on. Give me a big error or a something. That would be nice. Okay, let's that work for a bit. Let's just go back to my drawing. So what we did right now was actually using my identity when developing locally. So I could use my own identity when developing and granting access. Since I have granted access on my part, I added a owner, I think, data owner, I think it was. And then I could use that part in actually to publish messages on the Service Bus using my identity. So this gives us a way of being a developer and at the same time using identities to connect, which is a good part. There we go. And we can also see executed. Okay, let's just one more time. Let's see. Nothing. Let's just click to run. Let's see. Come on. Ah, there we go. No interrupt. Whew. Thought that was something bad. Must have done something hiccup in the beginning, or my local development maybe. So you can see now we should have the MSI message. Perfect. There we go. So now I've been able to do this on my own. And from a Azure perspective, you will have the same thing. So I actually have published this on the forehand. So the same logic actually. So publish a key and publish a role-based access. If I go back to Postman, we can actually use this role-based access and press send. So now we're sending to that instance over here, which is using we're going to this one, which is using role-based access, and that will give us hopefully a good one. There we go. So I get a 200 OK, and but if I go to my Service Bus publisher key and try to use that one, I will get an error because I disabled the whole static key part. So that won't work. Let's just wait and see for the error. But that's the idea of not giving out. So meanwhile that's working, we can just go ahead into configuration. And we will see soon enough, I guess. Come on. There we go, 500 internal server error. I don't have any good answer, but that's what I was hoping for. And if I go to read messages again, I will see the messages. But since I've disabled the local authentication, I can't use that anymore. And as you can see here, I'm using the fully qualified namespace again. Another part that I can show right away here is that we can actually do the same thing for Azure Web Job Storage. So I can actually, just go ahead. I can actually show you all my settings here because nothing is actually, I have no keys in this anymore. I just removed all the keys. And so for using a storage account, you will add this __ account name. And in order to use I use Key Vault to do this last part because I couldn't solve this one, so I put it in Key Vault. And I can also use role-based access to grant access to Key Vault as well. So let's just take a small look at that. We can start with the storage account. So on the storage account, we have same way of granting access. I wonder if we could do like this, by the way. I'm going to try something new. Let's go to identity and see what permissions we granted on it. I think you can actually go in here and you can see what we have granted on it, if I'm not mistaken. Let's hope for that, since my Azure portal today is a little bit slow. Let's hope for that. So the idea here is to just remove all the static keys and make sure that we're using anything else. So this is a system assigned, and we talked about user assigned, so we can add the user assigned, which will be something that we could create on forehand, which is a good one when you're doing massive deployments to production and you have a very strict infrastructure team that want to make sure that they have everything sorted out on the AD side. Otherwise, you can use the system assign, which I'm using. And if we click this role permissions, I think we can see the roles that I've assigned to this particular identity. There we see. So I have the data owner, storage blob data owner on the storage account. I got the Azure Service Bus data owner, since I want to publish messages on my queue. And I got some more storage there. And I also got the Key Vault secret user, which means that I can read secrets with my user on this particular Key Vault. So all of this can actually be put into an ARM template as well. So we can publish this with an ARM template and do, or a bicep for that matter. So we can actually do this in a release as well, which is quite cool. And it takes away a lot of headache of managing keys, and also they're not able to wander off anywhere because we need to have a valid AD account. And as soon as you kill this account, this won't be an access anymore. Kill my account for that matter. And if we take so we took the storage, the service bus, storage account, and the Key Vault. We also have the same thing we can do for Cosmos, as I mentioned, the Cosmos version. So in Cosmos, we can actually do similar parts. So let's just take a look at some code. Let's just take the rule-based access one. So Cosmos can do this as well. Let's see the settings we have, just to make sure we have settings. So as you can see, we have a Cosmos connection, and there's the full-blown with account key and everything. So this is the static key part. And we have the get items. So I have two operations in this one. I have the get items who's using Cosmos DB as an input, and we get the connection string, that static key we added over there, the settings. But if I want to use Cosmos with my MSI credentials, as I did with the service bus, I actually, at this point at least, I need to use this technique. I need to use this default Azure credentials, which is a way of saying to functions runtime that I want to have the credentials, and it starts with MSI, and then it goes to check the settings and so forth. So this is, and when I use this locally, it will take my account that I showed you, the one on tools and options, and the one I've set up in this Azure connection. in this Azure Service Authentication. So it will use this account, and when I deploy it to Azure, it will use the MSI. Then I can send this into the Cosmos client, and I can execute that one. So let's just see how this goes. Let's use demo. I think we will actually have both working right now, or I've been good and I've been turning off. Let's verify. So I'm going to use the Cosmos role-based access off. So let's just see, we got the Cosmos key. And so this is the key operation, which is a static key, and this is the one using role-based access. So we can actually set a breakpoint, because this could be a little bit interesting to see this service comprehensible part. Let's see where we go. Where are we? Oh, it's starting up. Oh, is this still? Sorry, I didn't know that I was having this one up. Sorry. That one should be killed. Otherwise, it's going to be tough starting up. Come on. Dun, 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 dun. There we go. We need to kill this one, and we need to create it again, since it was a conflict. Even if my computer wasn't really showing it yet. So we will use my step over here, and we will use role-based access and Cosmos key. Let's see how the setting is done on this secure Cosmos, because the secure Cosmos is the one we are calling. I don't think I have any data in it. I think it's just for access. But still, let's just see how the setting is. Let's just see. Let's go ahead. We can use this JSON view. If you haven't used it before, it's a good way of seeing all properties on your resource. And we can just go ahead and just pick the last one, because it's not part of the previous one, because this wasn't something you could do earlier. And let's see. We have local something, I guess. Local something. There we go. Disable local auth. True. So in this case, it shouldn't be working if I use a static key. So that's the setting we are using. And let's just verify that's the case. See that this is jumping off. Come on. Hello. That doesn't look good. Let's just see if we have something that draws a lot of resources. Let's try again. I'll let that work a little bit, and we can go back. But this says that I can't use local auth, which means that the keys that you can find under the settings over here is not going to work. So you need to have MSI again. One problem with the Cosmos is that you are not actually able to grant this access to the access control IAM yet, at least. I'm not sure if it's, I hope that it will come there. I haven't heard anything, but I hope it will. So in this case, you actually need to do a small PowerShell script. So let's just take a look at that while we wait for the other one, because they have added some functions in this as a specific role. So on storage account, on Key Vault, and on Service Bus, we could actually use the roles that is inside of Azure, the access roles, and but for Cosmos, it's a custom Cosmos role. actually. So let's see. I'm doing too much. There we go. So in this case, you will actually have this AZ command, Cosmos SQL. It's only on SQL right now. Role assignment create. And then you need to add the account name, the resource group, the scope, which could be one collection, for instance, or it could be everything, like I am adding, or one database. And then we need the principal ID, and then we have the role ID. And for this is the read only, and if you add a 1 on the end of this one, it will be a multiple read write. Then you just need to have the different names and the principal IDs. And then execute this one, and then you can add the role. Oh, now my function actually started up. Let's bring that in. So there we go. We can see that that's working. And let's go back and let's just have the failed one. Let's start with the failed one. It's always fun when it fails. So now we're trying to access with a key. Do we have a output maybe? Nope. Nope. Internal server error. That's nice. And we can see on this one that there was an error. Local authorization is disabled. So if I switch to the role-based access instead, and I press send, we will use my identity. We'll go back in here in this service principal class or object, and that then will pick my user, and it will connect to Cosmos and deliver some data back. So let's just see that we get some data. And hopefully we should see some data in here soon. Let's go ahead. Come on. A good thing, or many good things with this, is that you will get away from static keys, as I mentioned. It will be easier for security purposes. As a consultant, it's very nice to not being able to leak keys anywhere, since sometimes you just need to get access in random environments. And it will also give you can do all of this in deployment time using ARM template biceps. But you need to have something called a role owner, I think it was called. Let's see that while we are adding this one, just to make sure. Let's just verify what the role name is. Because now I forgot about it. Owner. Permission. Maybe I have it in my docs. I didn't. Interesting. User administrator. User as access administrator. There it is. So this role you need to have. Then you can add access for users, which will work on managed entities and so forth as well. So if you don't want to give the one who's releasing, the release service principal used for releasing, the owner role, you could use this and contributor in combination. And you can assign it on different resource groups or what level you want to have it on. Let's see. Oh, it didn't go well. Service unavailable. Interesting. Let's try one more. I wanted this to work. It actually worked before. I just tried it before. So let's see. And while we wait, let's see if we have something to show. Yeah, I think we're quite good. We have some pros and cons left. So let's jump into that. That is supposed to be working at least. We can switch on to it later if we want to. Make sure it's working. I would say, for my sake at least, the biggest thing is, from security-wise, is that we can remove all of these static keys. It's good on both security, it's good on deployment side, because we don't need to make sure that we are regenerating keys or having key cycles and so forth. It's a bit trickier to get started with it, as I mentioned, because you need to have some different access than you had before. You need to have this, as a developer, you usually don't have that much AD access. So this one, you need to top a little bit more, which means that there's some startup hiccups you will run into when you start using MSI, depending on the level of access you are granted. But you can use the user-assigned identities to make sure that you can have infrastructure, people actually preparing your identities, granting the access needed, and so forth before your services is coming in for a release. So that's good. Also make sure that it only works on internal resources. It's only working on the one you have access to, so you can't use it for an external resource, for instance. But I'm not sure if that's a big one. You could use an AD application instead, in that case. And also important that access is needed to be granted on the resource. You can't grant like service bus data owner on the subscription. You need to add it on the resource. And you even, as I mentioned before, you even need to add it on a specific queue if you want to have a listener, for instance. And that's important because that's part of the security mechanism, that you should specifically grant access on a specific resource that you're going to use. And very good to have no more leaking keys and access wandering off, I would say, in my case. And there we go. Questions? Oh, look, I got data from my postman. I just want to show them one. So this is working, yeah.
Perfect. Thank you very much, Mattias. I don't see any questions in the comments. It's not too late to post your questions. Mattias will probably answer them in the comments. I really think managed identities should be the default going forward. So if you're starting up, look into it. I would also like everybody to go into our Menti and give some feedback of today's event. Again, thank you very much, Mattias, and we'll see you in 10 minutes for the next presentation.
Thank you very much, everyone.
All right. Hello, everyone. If there are any new joiners, welcome to Global Azure Norway 2022, day 1. We are ready for our last session of today. And my name is Kristina Devochko. I am one of the organizers, one of the board members in Norwegian.net user group Oslo. And for this session, I would like to introduce our great speaker, Mikael Aas. Mikael Aas is a manager architecture at Sopra Steria and is an experienced architect with long experience of .NET, and he demonstrated the benefits of .NET 1.0. Just think of it, when it was still in beta. So it's a pretty amazing experience. And Mikael is interested in technology at the intersection of things, from front-end to back-end development, and then operations onward to users and organizations. So, Mikael, what are you going to share with us today?
First and foremost, my screen. And I'm looking for that funny little button that will make that happen. I'm in the StreamYard right now, but where's the share screen? Do you see my screen? Nope.
No, you
there it is.
Can see it on the bottom, yeah.
The wonders of technology. Now, once that's done, can you please repeat the question, Kristina?
Yes, so we can see your screen.
What was your question?
So my question was, what would you like to share with us today in this beautiful evening? An exciting story.
How to do mission critical things, which is with no errors whatsoever on the cloud. And now as I share my screen, we can start talking about that. But I remember when you told about .NET 1.0, that was the days. It was good times. We were all very proud of what Microsoft had accomplished, and we felt that this was the way to build software for all businesses. But that changed, unfortunately. So if I just swap to my next slide, in 2014, I arrived to Norway. And in the summer there, I was taking a hike up to one of the mountains. I don't remember which, but it was foggy up there and we could barely see. And then there was an old timer there who said, well, you got to watch your step because it's a ravine over there, and if you fall down, you hurt yourself really bad. And we were pretty scared, and we decided to just walk back home very slowly and not go back again. And I say this because at the time, if I was building mission critical things, modern web application using Azure, get the same experience. It was foggy up there. It wasn't similar to this picture here where you have a very clear path and in the distance you see where you're supposed to go. Microsoft was lacking. Microsoft wasn't where the other two competitors were, AWS and Google Cloud. So today I'm going to talk about why was it so complicated to build mission critical on Azure in those days, and what has happened since then, and what is the dot on the I that Azure Mission Critical project has delivered. I work at Vipps during my day job. I'm a consultant for Supersteria, helping Vipps, and we are using Mission Critical to make important design decisions. I'm going to share some of them with you. Should just get an insight on how you can use the Azure Mission Critical. And then at the end, some thoughts on how to get started for those that wants to use this and build better production code on Azure. But first, let's clarify a thing. What is mission critical? Well, it connects to reliability. We want to have uptime. We want to have operations succeeding according to expectations. And when it's mission critical, we talk about 4 nines or above. Not your average line of business application. We're talking about Netflix, and there's some really big stuff up there that where it doesn't work, it gets on the news. Vipps is a little bit similar to that. But not only that, because we also want to have high development frequency. We want to have an application that evolves, that you can upgrade, and you can do it with confidence, similar to what we have as an elite DevOps performer. Those two things, you have a mission critical application. So on Azure, this has been complicated. Why? I'm a little bit of a history buff. I look at history for explanations, and I many times find the answers there. When we look at the history here, AWS came out in 2002, and Google came out in 2011. Microsoft came with Azure in 2010, but that was Windows Azure. It wasn't until 2014 that Microsoft said that, okay, it doesn't matter who builds it, we're going to offer the best possible things on Azure. So you could build the high-class mission critical that all the others been doing for a while. And when I say a while, Google started building their applications in 1998. That's 24 years ago. And they've been building mission critical since then. And when they started opening up how they're doing things in 2011 as part of Google Cloud, we as an industry, we're just impressed. And when it comes to Amazon, it's similar, but in a different way, because they are market leaders in the US. So there's lots of public information for Netflix and Twitter and such, who are all Amazon customers and using AWS. Microsoft has been behind, and it wasn't until 2014 that they had the technology. And this is the .NET Forum. So when it comes to the .NET, it wasn't until .NET 5 2 years ago where the primary .NET version was not Windows connected. We could use Linux in combination with that, all these things. So you need that because basically you want to do cloud native, and when you do cloud native, you want containers, and you don't very often hear about Windows containers because they are not suitable for mission critical. So think about myself. I have 4 important needs when it comes to around mission criticals, and they were before unfulfilled. Microsoft is very good at providing code examples. And there's a design criteria when it comes to writing things for Microsoft, creating new products. Can I demo it quickly? And I know that. I used to do it back in the days. We could demo things quickly. But then there was the next step, or a couple more steps, which was making this code into production. How do you write production code in .NET? There's like a little bit of void there, and there still is. And when it comes to Azure, the background here is not to have one simple way of doing things, which was originally how Google was, because they had a very opinionated platform. Microsoft has provided a lot of things in Azure. So there's so many things that are overlapping. They can do about the same thing. So when I'm doing mission critical and these choices are suddenly very important, what shall I choose? Mission critical on a global scale, then you are multiple multiple regions, I was about to say. Of course, you want zero downtime, be able to update, and you have to have continuous delivery. Combination of those three things is a question mark. How do you do it? And at the end of the day, you just sit there and it's like, hey, I just want the expert. I want the guy who has been working a lot with this, who is giving me the information I need so I can build the things that matters to my customer. All those things were unfulfilled until the Azure Mission Critical project became public domain as it became open source. This happened a couple of months ago, but the team, the Microsoft customer architecture team, had been working on this for some 2 years, and they have accumulated some 50 customers now. Let me share that on my screen. Let's see now. Oh yeah, there will be this one here. And we'll put it there so everybody can see it, and we'll go to the actual repo. So what we have here is shortly what this is about. It's a methodology and its approach, and it also has some reference applications. Let's scroll down and we can see them. There are 2 reference implementations. One for online, which is when you are on the public but not connected to internal enterprise resources, and one connected, which you need to be on the VNet internally. And then there's some information on how to proceed with these. Let's go into the online one. And here is, I'm going to talk more about what that means and how this all connects. And then when you click down here, you will find different kinds of designs that's been made and then arguments on why these designs were made. And
Mikael, I'm so sorry. Can you please expand your browser? It's a bit small font. Thanks a lot.
No problem. Thank you for letting me know. And finally, when you get interested in this, I recommend the Getting Started section, which helps in terms of setting up one of these reference implementations on your own subscription. Okay, let's go into here and continue on. So that's the GitHub repo. On a larger scale, what this is a design methodology for what features of Azure should one choose when going mission critical. Also, there's an example custom application that shows a little bit how things are connected and some code around DevOps and operations and how to hook it all together. And to the left then, there is the patterns that all mixes this together, the guidance on how to build based on this, and the reference implementations that can be used so you don't start with an empty white paper. This is really amazing stuff, and I'm really excited about it. A really cool note is that before, when it comes to the 12-factor app, which you can read about in many other environments, it was hard to find information about that related to Microsoft. At least I didn't know aware of anything, but here it is. You can find it in the GitHub repo. The team behind this has been very clear that when it comes to making architecture, you always do trade-offs, and this is no exception. And they're very clear on, okay, what are we prioritizing here when we're building this architecture? And to the left is the maximum reliability. The application needs to be reliable, and that is where we're prioritizing. Hand in hand with that comes the sustainable scale and performance, where there are peaks of load, lots of users want to use your application, that will be reliable. So those things are to all come together. And that's why those are the 2 primary design principles. Operations by design is to make sure that we can, under a very controlled fashion, update this application. We always want to secure, but it's not the primary focus here. It's some of the things needs to make sure that It's secure so the application doesn't go down. Cost is important, but as you can see, it's further to the right. On the foundation here is cloud native design, which brings it all together. Let's be a little bit more concrete. How does this look? In the repo, we saw this architecture map. And let me explain how this all fits together. There are two kinds of resources in this. We've got the global resources on the top, and these are different kinds of services that Microsoft provide, which they host globally. They're not connected to a region, and they offer SLAs which are much higher than is possible within just one region. And then we have deployment steps. Here we have deployment step in region number 1, and then the idea that you can apply more deployment steps in another region. And usually it is one stamp per region, but it's technically possible to have multiple stamps per region in this architecture. 3 is recommended. That is what gives a nice reliability, but it's been tested with many more, up to 10. And then within here, there are some design decisions. You can see that AQS is used, and the team has just basically said that this is the strategic direction which is happening. When you're going greenfield and doing mission critical, AKS is the recommended compute platform. Service Fabric was before, but not anymore. Of course, for customers and teams that feel that this doesn't work for them for various reasons, they can choose something else and swap it out. Further down here in the D, we have the health service. The responsibility of this is to determine, is this region healthy? Do we have storage account? Do we have the Cosmos running? Is the Event Hub running? Is everything healthy so the application is continuing and running? And this is important because up here in global, there are the front door with its routing rules. And it checks the health services and determines if a stamp is still available to take traffic. And when the health service says nope, then the front door will direct traffic to elsewhere. The demo app here, which is on 3 containers on this cluster here, and 3 pods obviously running in the pod, is a decoupled to just show how to build something which has high ability to handle peaks of load. As the first one handles just reads and very quickly responds. And when there is a need to write, it puts it in a message in the Event Hub, and then in the background processes, there are writes. And one can monitor the time of the Event Hub to see if the application is getting overloaded, and if in that case, adjust the availability of more stamps. In this case here, when we're talking about global mission critical, front door is the recommended load balancer. And it has abilities which works really well when the users are distributed all across the globe, and other mechanisms in terms of caching and firewall on the edge. Cosmos here is the recommended database storage. The primary reason here is that it supports active-active. You can have 2 stamps in 2 different regions writing data, and Cosmos will take care of it, making sure that things are consistent at eventual time. There are other databases that have been tested, but it gets more complicated. So if one can, the recommendation is to use Cosmos. And what this does is that in the case of a problem, health service reports this region 1 doesn't work anymore, we don't do failover. We just redirect the traffic somewhere else. Not the typical of, let's have everything standing cold in another region and we'll detect when we need it and get the traffic over there. Everything is active. And when there's a problem, we put something passive. And that way, nobody will notice. It goes really well. The key for this to working is that every stamp here is independent. There's no connection from a stamp to a stamp. Everything happens globally with mainly Cosmos, but also static content, which is then being stored in this central way here. And that when you deploy a new stamp, which you do in Azure DevOps, everything that the stamp needs is coming with a deployment. And regarding this design decision here to use Azure pipelines, Azure DevOps, templates at this time is more mature in that one. But the team, the architecture team, is noting that GitHub Actions is maturing, and expect that some future it will also be a viable option. So using this, how have we in VIPS applied this and done design decisions? First, let's start with a little bit of business context. The service that we're talking about is a new service, which is going to simplify handling identities of merchants. Let's just explain what that means. The typical VIPS usage, private person sending money to another private person within a family or to a friend or whatever it may be, is the one which is here to the right. You get two people, they all both have the VIPS app, and one person sends money to the other person. It's extremely popular. Everybody does it. I would argue more popular than cash in Norway. But VIPS doesn't make money here. This is a free service. Where VIPS does make money is when merchants are selling various kinds of products to private people. And it's the same private people which are connected to the VIPS network, as it's the same app that they have installed. And these merchants, they are either having a VIPS number that you can use and enter into the app, and thus you provide, or they have various kinds of integrations with their systems to the VIPS via merchant APIs. And of course, merchants also have complicated needs and such, and many times calls customer service at VIPS, and then there are systems to deal with those kinds of things. And all these, there are many different kinds of users, and these needs identities. And handling this is business critical, because here is where VIPS is getting money, and it's connected to a lot of services out in Norway, which are critical. And if you can't pay for those services, you won't be able to use them, at least not as convenient. Router is a very popular thing here in Oslo, and just going to buy things at the store, you want to pay with VIPS. There's just so many things that would become awfully complicated if this didn't work. So we're talking business critical. So the design principles that the team of Microsoft gave us does apply, but VIPS is a fintech company. So security is very important. It's paramount, and especially integrity. We cannot change the truth. It always needs to be protected. So when looking at these suggestions that the Microsoft architect team came with, we quickly decided that, we can't accept this. We need to move the design principle of always secure to the front. And then that cascades things and it changes things. I'm going to talk a little bit more about those details as we progress. In the repo, the GitHub repo, there is lots of discussions on how the architecture handles these different kinds of design areas. We've got application design, we've got data platform, we've got security, networking and connectivity, the application platform, typical Microsoft, Azure decisions, operational procedures, health modeling, which is really from a risk standpoint, how do we see that this thing is actually healthy, and then deployment and testing. These are the design areas which the architecture evolves around, and there's also these design areas that we have been starting to explore at VIPS. So we start looking at application platform, which is the kinds of services in Azure that one chooses to enable. The stamp methodology that this comes with works not so well with VIPS right now, because VIPS is one region. It's in Amsterdam. So the notion that we would apply things to different stamps and in different regions doesn't quite work. VIPS is in one region and has failover to another region, which is a passive failover. We have been thinking about, okay, can we put up regions in the same, no, can we put up stamps in the same region? And that would be a possible thing to do because it does come with benefits. When we looked at AKS and the idea that every stamp would have its own AKS instance, that doesn't scale very well with how things are done at VIPS. VIPS has a team that are responsible for AKS, and they do a tremendously good job, and handling of was quite complicated. And they share online on various sessions on how they do these kinds of things. They don't upgrade AKS. They create a new one and they move everything over, and they created procedures on how to do that. And the idea that all teams should do all this the same, again, that doesn't scale. So we're looking at different options here. We're not going to follow this recommendations, which is here. When it comes to up here, where teams have their own global resources or an application has its own resources, that doesn't mingle well with the security and the finance regulations, which WIPS is following and feel as very important, where this is centralized, controlled by a small group of people that are ensuring the security of everything. So what is recommended here won't work, and having separate cluster AKS Kubernetes clusters either won't work. So what we're looking at here is, instead of front door, using application API manager, and also having Flagger on the cluster level. Too early to tell exactly how this is going to evolve, but what we're thinking is, if we switch to the deployment and testing design decision aspects, what we're thinking here is, this is what Microsoft is recommending, which is, in short, deploy the global infrastructure, you build the software, you build the infrastructure, and then you deploy the things to stamp and you test. More about that. Use front door to put traffic onto it, and then gradually swift more and more traffic until you're at the point where everybody's happy, and then you can destroy the old stamps. We don't keep stamps which don't give traffic anymore. Again, front door won't work that well, so we're investigating Flagger, which is a cloud-native project within Kubernetes to switch traffic between different pods, which then typically contains different versions of the same application. Microsoft recommends Locust for doing load testing. This is high availability things, high reliability things. So we want to give something which is very, very similar to real production when doing testing. We can't just give it a little bit of traffic and think that that's sufficient. The recommendation here is to give it lots of traffic. It is a cost in terms of doing deployment, but it gets you a better confidence that things are working as expected. And regarding that confidence, what also is recommended, and which is quite cool because the Azure Chaos Studio is just kind of half a year old, is specific designs on how to then change or to inject error scenarios into this situation with a lot of load being artificially generated, and then seeing how the system handles that. It's really impressive, and we're planning to investigate how we can do the same thing in VIPS before things get real traffic. Now, this is real people, and we use BankID for identification, which means that Folkeregistret has come out with specific guidelines on how to have civic national identity number, Norwegian national identity numbers, which are not real people, but still valid, is really helpful. It's going to help us a lot with those guidelines. I spoke a little bit about data platform before. Let's talk more about that. As I mentioned, Microsoft says use Cosmos if you can. And in this case, in our initial discussion regarding this, we're coming to a feeling that we can't. We really like SQL. Azure SQL with the structured data and all the things that we just take for granted after having used it for a while. Cosmos is a document database. It has amazing performance. It has amazing distribution on a global scale, but it isn't as structured and easy to use relate to the data. It's basically a hash table. You can use the SQL interface of Cosmos, but pretty soon you realize that it's not the same. The data is that's not structured, so it's not going to behave the same as a normal database. That's when I say normal, I mean a SQL database. So we're looking at alternatives. And I heard from the architects team at Microsoft that they're also looking at how to do this with different kinds of database. So that's going to be very interesting when more of information of that nature comes out. For some reason, the Event Hub icon disappeared on this screen here. Interesting. I wonder. Anyway, for messaging, Vibs has pretty much settled on Event Hub. I'm going to talk more about that shortly in terms of what's it suitable. But in this case, we're looking at a queue, and that's pretty easy, not much to worry about. Moving further, though, when it comes to events and when developers start talking events, you have these different kinds of things of architecture when it comes to events. You have event sourcing, you have event storage, and you have event streaming, and you have event queue. In this demo application, which is part of the reference architecture, these are queues. It's you put it in at some point later, it gets done. Event sourcing and event streaming are different things, and then the Event Hub isn't as suitable. And we've started to talk about this in the team, what we're supposed to do, and it's all up in the air, but just kind of recognize that, decide what kind of events behavior you want, and based upon that, choose the different resources that is relevant. Okay, this is what we've done so far, but it's all very, very early in the process, so I'm sure this is going to change. What the framework has given us is a very quick way to getting started. We didn't have an empty sheet of paper. We got the best-in-class recommendations from Azure. It's been very, very helpful. So if you're interested in this and you want to get started, I've got 3 recommendations. I wrote star the repository. There are actually 3 repositories. But anyway, use the benefits of GitHub. Star these things. These are experts that are delivering the real projects for really critical solutions, and they're using that knowledge to put that into things, open source things that we can use. And by having it starred, you get notification when it happens. There's one more thing which is of interest here, not just of the deliver to the customer. It is that this team here is in tight cooperation with the product teams of Azure. So when something happens which makes the guidance change, different roadmaps and such, then this will come back to the architecture, and it will be really helpful for us to keep in track on the important things when we are delivering mission critical. That brings to the second getting started aspect. Early on in these framework, there are questions on, is your application or is my application mission critical? It's a critical question and it needs to be answered. And if the answer is no, which typical applications aren't, typical applications are normal, they are perfectly happy with 3 nines, then these things here are useful, but they're not ideal. So then look elsewhere for guidance which is a better fit for that application, which isn't mission critical. The third one, though, still applies independently if you're building a typical application or mission critical, whatever it may be. This is production code. There's a lot of production code here. And as it is production grade, there's a lot of really good things that one can pick out. I'd love to show it for you at some other time, but I recommend the front door code. It's really interesting. There's a lot of C# code for .NET, which handles various kinds of aspects. If you haven't written this kind of code before, then have a look at what the experts wrote. They've decided to use Terraform for the deployment, and the reasons are twofold. One is that there's a lot of customers out there, Microsoft customers, which haven't done Bicep because it's new, and also a lot of IT organizations out there, they're multi-cloud, and Terraform fits better there. So this implementation here is in Terraform, and if you're interested in how things are done, how Microsoft would do it, how the experts would do it, it's all there. They also have a lot of different kinds of Azure DevOps templates that one can see on how to do things which are critical. And connected to that is the how to generate artificial traffic, synthetic traffic, and how to also inject different kinds of error situations. Lots of very interesting production code. And I encourage you to go read it for what you're interested in, and at some later point, I will show more about that. Having said that, I wanted to say thank you. First, a big thanks for Global Azure Norway for inviting me to speak at this event. It's been great fun. Huge thank you to the Microsoft customer architecture team that's been doing this and also providing all these things, which is at the kind of the end of the journey that Microsoft's been doing now to allow us to build first-class mission-critical applications. And then also a big thank you to VIPS that is very generous in sharing what is going on within the organization so that others can also succeed in building their IT applications. With that, I give over to you. Shall I stop sharing?
Yes. Thanks a lot, Mikael. This is very interesting, extremely interesting session, and we actually have quite a few questions. So if you are ready, we can take up the first one.
Yeah, I'm ready. I was trying to find you on my multiple monitors. It's like, where's Christina? Where is she? Where is she?
Go follow my voice.
No, that doesn't work in this world.
Yeah. But we have a question from Jakumar. Question number one is, how long will it take to create new stamp?
That depends on the speed of the region. And it connects to that you create a lot of traffic and you pull it onto the new stamp in part of creating it. And the various testing that Microsoft's reporting, it is between 10 to 30 minutes. And again, the mileage varies if one does it on their own, depending on the application and how much testing one would do. But the recommendation is to spend that time to have the assurance that this is something that indeed is ready to go to production. Good question. Thank you very much.
Absolutely. Jakumar has one more question, actually, and that is, what tool is used to provision Azure resources from pipeline?
That would be Terraform. I mentioned that at the end. I noticed, like, oh, whoops, I'm sorry, I should have mentioned Terraform. And again, Microsoft came out with Bicep, and they are what the team used to do was to have both a Terraform and a Bicep implementation in parallel, but then they decided that was just too much effort. So you can do all these things in Bicep, but for various reasons, the Microsoft architecture team has in their reference Terraform.
This is actually very interesting. I was recently in a meetup with some representatives from VIPS as well, where they have been talking about upgrading AKS in mission critical environments. And then they mentioned about that they were more excited for Bicep than Terraform. So Terraform was not 100% fit for them. But that was,
the reason for that is that VIPS, there are multiple reasons, but one very important one is that VIPS has gone full Azure. There is no other cloud at VIPS. So in that case, it makes perfect sense to choose Bicep, because Bicep is a variant of ARM, and with ARM you can do everything which you can do in Azure, and it kind of fits together. And then Terraform is a little bit more complicated, as it has state, and you have to maintain that state, and God forbid if you don't and it gets corrupted, you're in trouble. Bicep doesn't have that. There is state, but Azure maintains that. Basically, they ask Azure, what's your state? And based upon that, it makes decisions on what needs to be done, which makes it more safe to use. So my recommendation, when you're in a situation like VIPS, only Azure, then start with Bicep as your baseline, and if you find a reason that it won't work for you, move over to something else, such as Terraform.
Yeah. I guess Terraform state was precisely the reason why they didn't like Terraform so much, because that made them suffer a bit.
True. I mean, but the state does come with benefits. You just have to maintain it. It's important. And that's one of the reasons why Terraform costs money, because when you do buy their professional version, they manage state for you. At least that's the way it was 5 years ago when I worked with it myself.
Yeah, but really good questions. Thanks for clarifying that, Mikael. We also have one comment from Torstein. Thanks for sharing this. I learned some new things, and I can back that up as well. So that was really interesting to know more about.
Well, I didn't know that I would talk quite that quickly. In that case, I would have shown a little bit more code and some other aspects. But I do encourage you, Christina, and everybody else, go into the repo and start reading things that you're interested in. And it's hard to me to know what you personally would be interested in, but you know. So go into the repo, see on how to do various kinds of things in C#. And we're talking production grade, not the typical answers on or the typical code that looks nice, but would fail in certain scenarios. Go in and read the code. That is the value that everybody can take here. And when you're in a situation when you need to build a new service, a new application, and people talk about it being sort of level of criticality to it, an architectural role, senior developer, tech lead, or such, then take the whole thing. It's I think Microsoft's have done a really impressive thing here, but unfortunately they're kind of 10 years late. But hey,
you know, there is a saying, better late than never, so we should be happy for that as well. Yeah, but I think it's a really good advice, learning from the experts and learning from others. Good code.
Windows is great. I use it on all my client computers, but I would never use it in server. And that Microsoft has stopped forcing us to use Windows. That is what kind of started this avalanche of possibilities, that we can now build the best stuff using Azure. It's just a start. I think it's going to be even better.
Absolutely. It's extremely exciting to follow all the development and how much was achieved during just the last few years. It's extremely impressive. So yes, thank you so much, Mikael. I don't think there were any other questions in the chat. I don't see any. I guess there was one more question regarding how did you actually find or came to mission critical system design? How did you end up there?
So there was a time when Microsoft's repos on GitHub were everywhere. They had a little bit there, a little bit there, a little bit there, a little bit there. But they've done an effort here on putting things together. So there is a few projects that you can go to, and there is relevant information. And this is the Azure project in GitHub. So from time to time, I just go there and say, hey, is there anything interesting going on? And looking at the different kinds of stars and things, and there it was. And I just was surprised. I was just like, whoa, this was interesting. And I clicked on it, and the rest is the reason why I'm here.
The rest is history.
I would say it's the current.
Current with under active development.
Yeah. Now, talking with the team, the architecture team, one learns that they've been working for this for 2 years. And it's interesting enough that 2 years ago is when .NET 5 came. So that's where .NET Core, which was the kind of the main alternative at the same time as we had .NET Framework on Windows, was replaced with one.NET. And at the same time, Microsoft got serious about delivering mission critical to various customers. And also customers got comfortable about asking for it. But there was a need, and in Microsoft, they got this team together. And I'm really happy that now Microsoft is the sharing culture. So that they put in the effort to make it all available. And now anybody who is looking at the different kinds of complexities which is around this doesn't have to start or reinvent the wheel. And as I was telling the story about being in the fog in the mountain, when you do reinvent the wheel, many times you end up getting pretty badly hurt. And when you're in the world of mission critical, that's not a good option.
I totally agree. Absolutely. So I'm also really happy to see how much Microsoft has been supporting also open source and has open source to themselves. So really happy, and I guess most of the tech communities as well. So
yeah, I agree.
All right, so there is one more comment from Oddbjörn, who also thanks for the talk. And thank you so much. It was a big pleasure having you here. Exciting topic. I wish you a great rest of the evening. And I wish the same for all of our seers, participants, and those who will watch this recording. We will also very much appreciate if you can take a minute or two and just follow the link, which we will shortly see on the screen. There is a Mentimeter. Please let us know how you think the first day of Global Azure Norway is going, and leave us some feedback. We'd love that lots. And we also have a QR code, which probably will cover Mikael here, but there it is. So yeah, there you go. Mikael is still there. So please follow that one as well if that's easier. And thank you so much. We will see you tomorrow at day 2 of Global Azure Norway 2022.